because my video should work. Oh, from last time? Come on. I need a projector. Give me just a second. We might have to work with no projector today. I'm trying to get us in a different room, but no one's answering their phone. So it's okay because the worksheets will explain themselves anyways. It just the visual I think helps you all learn a little bit better. So hey, well, this is Jason Mack. How you doing this morning? Doing all right. I am in room 3G, big 3G06, and my projector doesn't work. Is there another room that has a projector? Because I'm teaching stats. It would be easier to teach with a projector, but if there isn't, I can make it work without. I'm calling from the classroom right now. Yep. I had to where I don't even see a phone here. Where would it be? I'm calling on my cell phone. Oh, there is a phone. Hang on, there is a phone. There's an extension. Oh, there's no like hidden right on the wall. Okay. All right. My extension is, I believe, four, 4230. Well, we wait. We'll start with like. A little. I'm not sure if it's as funny as the rat problem, but we can start with the funny story until they call me back. This is my adorable niece there. In the picture. So the first time. So first time I met her, she grew up with her parents speaking English and Spanish to her, so she's like super fluent both ways. But we thought it'd be fun to make my brother-in-law think that I didn't speak any Spanish for like 6 or 7 hours. So we had his wife in on it. Um, and I kept like saying like 2 or 3 words for several hours, and I would like mess up like the verb conjugation. I like use like the infinitive. I'd say it like wrong on purpose. So finally, after about 6 hours, he's like, "So you can't follow us tonight when we speak fast Spanish, can you?" And then I like said a paragraph to him in Spanish. I was like, "Gotcha." So, she spoke Spanish. My little niece Sophia spoke Spanish too. Everybody except me that weekend. The person she speak English to was quite adorable and endearing. So, but now she's like 10, so she's still adorable. But like when she's a teenager, it's probably just all over. I'm waiting for the projector for everybody that's just joining us. So we're probably gonna have to move. They're making some calls and calling me back either in that phone or on my cell in a moment here. Because I feel like you learn better when I can show you the stuff. It's just not working. I've turned it on like several times. Everything except the projector is working. And I can use a whiteboard. I mean, I can do it without. It's just easier with a projector. So 8:30. I just double checked the points this morning and re-added everything to make sure everything made sense. It's 8:30. So you should be sitting at like 5 to 700 right now, at least, approximately, because you got 100 points on the exam. There should be some websites that may or may not have come in yet. I just did a bulk import this morning. So anything that like was due at through yesterday came in today. Now I can certainly, you can retake pre-tests and post-tests all the way until the class ends if you want to try to maximize your points. Fix there's extra credit for chapters 15 and 17. I think those are each 15 points. But for that to work, you have to forward me the results and you have to send an email directly after because it doesn't tell me your name. So I can use a timestamp to be like, oh, that's Alexa, that's Jonathan, Annie, whatever. That's why you want to do that. And then if you write a review and write my professors and screenshot it to me, 15 extra credit points for that too. So about 45 extra credit points. Hope you all have awesome stuff to say, but of course, be honest. So like if I'm not doing great, you can say that too, but I hope that I am. And then what I do is I look one by one at your emails right before final grades to apply the appropriate extra credit points. If I see the timestamp on the quizzes and then I see the screenshot with your name, then we're good. So as soon as they call back, hopefully it won't be like several minutes. I could probably start explaining without the projector and then just hope they give us a room soon. I can tell you where to navigate. It would be the class, student resources, in-class activities. And then of course, like our hard deadline would be your reviews would be due tomorrow night so that you can present them on Wednesday because Wednesday's our last time we're meeting. Yeah, but we're on chapter 12, so we're okay. Because that's it. I only teach through chapter 12. So I give you the foundation on Wednesday, and I have worksheets that'll really break it down that we'll go through today. And we have like 2-3 worksheets max left, and then our reviews, and then I might do another worksheet with some points for exam 3 review, potentially. So like probably 2 to 4 worksheets more, and that should take us through the remaining 8 hours we have. No. You can learn that on your own if you want, but no. No, because that would be too many points. But I appreciate the spirit of you asking for extra credit. That's awesome. I do have an exam 3. I do have an exam 3 final review, so I can make that available actually. So where you should be is student resources, in-class activities, in-class activities week 7/13/22 part B, and then we should have chapter 12 worksheet statistics. And we'll start with that. So why don't we start with that, and then I will walk you through. Oh, maybe not. Don't start with that because that's got calculations that we only went over once. In fact, start with, instead of this chapter 12 statistics worksheet, we'll do student resources, in-class activities. Is the one that I want? Yeah. We'll make this in-class activities 7/25. 22. We're gonna do chapter 12 review deep dive. Does everyone see that? Hold it, not give me chapter 12. We're gonna do the chapter 12 review stats review worksheet. And for some reason that's not showing up, so give me just a second so I can add it. Stats. It's got student resources, in-class activities, it's got today's date on it. And I can walk you through that. I just can't put it on the screen at this point. But I have to add an assignment. Hang on. Browse. Downloads. Submit. Did everybody find that? There's a doc file, chapter 12 deep dive. It's got in-class activities and then it's got today's date. Chapter 12 deep dive, and then there's some Excel sheets which we're going to need to reference, but we'll start with the worksheet. So just to review, the levels of the factor are symbolized. Does everyone have the worksheet up before we jump in? In-class activities, student resources in-class activities, look for today's date, chapter 12 deep dive. And we're going to walk through this in detail. And then that should get you all to clarity. And then I have a worksheet or two that are a little easier, which I can give you time to work on and walk through the answers. Then I have an exam 3 review, which is like walking through all the information again, which should get us there for the test. Does everyone have the worksheet up? Did you all find that? Got it? Got it. Okay. So the levels of the factor symbolizes K, the number of groups. You might remember that from Wednesday, in ways which independent or quasi-independent variables observed. Remember, what we're talking about is if we have 3 groups, we have 10, 10, 10. K is 3 because we have 3 groups. This would be N1, N2, N3, and N1 plus N2 plus N3 is equal to N, which should be just review from Wednesday. Analysis of variance measures the variance among 2 or more groups. Analysis of variance is called an ANOVA. Don't let that the name of it freak you out. It's a statistical procedure to use to test hypotheses for 1 or more factors concerning the variance among 2 groups or group means. K is greater than 2, where the variance in 1 or more populations is unknown. If we look at a one-way subject ANOVA, different participants are observed at each level of 1 factor. A one-way between subjects ANOVA is a statistical procedure used to test hypotheses for 1 factor with 2 or more levels concerning the variance among the group means. This test is used when different participants are observed at each level of the factor. And the variance in any one population is unknown. A between subjects design is a research design in which we select independent samples, meaning that different participants are observed at each level of a factor. A one-way between subjects ANOVA can be used samples selected from 1 or more populations. For ANOVA, K is the number of groups, N is the number of participants per group, and N is the total number of participants in a study. There are 2 sources of variation in the one-way between subjects ANOVA, one way attributed to differences between groups, and one associated with observing different participants in each group or within groups. Between groups is the variation attributed to the mean differences between groups. A source of variation is any variation that can be measured in a study. For example, in a one-way between subjects ANOVA, there are 2 sources of variation attributed to differences between group means and variation attributed to error. Within groups variation is the variation attributed to mean differences within each group. This source of variation cannot be attributed to or caused by having different groups and is therefore called error variation. An F distribution is a skewed distribution derived from a sampling distribution of F ratios. The variances measured in a ANOVA test are computed as mean squares. A mean square is a variance. The two terms mean the same thing. They're synonyms. The formula for the test statistic called the F statistic is the variance between groups or the mean square between groups, which is written like this: mean square between groups divided by the variance between groups, or mean square within groups. Mean square within groups is more commonly called the mean square error, not within groups. The formula for the test statistic is this: F obtained value is equal to the mean squared between groups or variance between groups divided by the mean square error or the variance within groups. Variance within groups. The test statistic for ANOVA measures the variance attributed to the mean differences between groups. Mean squared between groups divided by the variance attributed error, mean square error. The F statistic or F obtained value is test statistic for ANOVA. It is computed as the mean square or variance between groups divided by the mean square or variance within groups. The mean square between groups is the variance attributed to the differences between group means. It is the numerator of the test statistic. The mean square error or mean square error within groups is the variance attributed to differences within each group. That's our denominator right here. The degrees of freedom between groups are the degrees of freedom associated with the variance of the group means in the numerator of the test statistic. They are equal to the number of groups, k minus 1. So degree of freedom degrees of freedom between groups is equal to k minus 1. The degrees of freedom error or within groups, or degrees of freedom within groups, or degrees of freedom denominator are the degrees of freedom associated with the error variance in the denominator. They're equal to the sample size n minus the number of groups k. So degrees of freedom error is equal to n minus k. That's a lowercase k. The variance for the denominator is attributed to error. The degrees of freedom for this variance are called the degrees of freedom or degrees of freedom within groups. Okay. The reason for the reference to the numerator and denominator for degrees of freedom is that there are two sets of degrees of freedom, one for the variance placed in the numerator of the test statistic between groups, and one for the variance placed in the denominator of the test statistic or error variance. So F obtained value variance between groups. So you can also look at it like this. You can also look at F obtained value is equal to the variance between groups, over the variance within groups, variance within groups, which could also be k minus 1 over n minus k. So let's look at the degrees of freedom using the data in 12.2 of our textbook. This hypothetical study, as everyone see 12.2, we had a one factor type of class with 3 levels of psychology, sociology, and biology. K is equal to 3. Does that make sense so far? We observed 5 students in each class, n is equal to 5 for a total of 15 participants in the study, n is equal to 15. Make sense? Because n is 15, the degrees of freedom for this should sum up to 14. N minus 1 is equal to 14, right? The degrees of freedom between groups in the numerator are k minus 1. So degrees of freedom between groups, 3 minus 1 is equal to 2. Are you with me so far? Front row, back row, makes sense? Left, okay. Yeah. So we are on page 3. So if you're trying to follow, oh, thank you. I'm so glad you're here.
Yeah, no problem.
Jason, what's your name?
Projector?
What?
It's Caleb.
Caleb, nice to meet you.
Nice to meet you as well. Issues with the projector, you said?
Projector will not turn on.
Not sure. At all.
We're making it work without it, but
Okay.
it would be helpful if we can stay in the room because we have some specific software for stats on all these computers, but if we can't,
Okay.
and whatever is the best for you for MO, I can keep teaching, or if you need a few minutes to look at it, or if he's gonna distract you all a bunch, then we can.
It's not getting any power.
Okay.
There were a bunch of storms over the weekend.
Oh,
So I can call facilities and I can make sure that outlet is working.
it's probably a short or something,
Right.
or a circuit breaker.
Yeah, it's probably a circuit breaker. So
Okay.
I will call them and let them know that it's not getting any power.
Okay.
Let me see. Does that know what?
Gustavo, in class activities, student resources and class activities, look for today's date, chapter 12 deep dive. We're on page 3. And that's everything that I just talked about too, is on there against the whiteboard. And we're about halfway down. If you want to follow along, or if you two know where I'm coming from, you can maybe show them right where we're at. And then maybe like just tell me when you're able to pull it up and everything before I keep going, just so you're not lost or anything, Gustavo. Just tell me when you're at this spot on the worksheet before I start talking again, just so that way. We had a tornado warning in San Diego a couple years ago when I lived in San Diego, and nobody knew. They were like, just go to the basement, guys. Just go to the basement. Like, it's not a big deal, but they never ever have tornadoes or ever. They always have earthquakes. And like a structure like this is probably going to be fine if there's a tornado. But so what'd you do? Did you like just go to the basement or whatever? Oh, you didn't know? Did the sirens speak? Oh. Oh. Probably should duck for cover. Probably wasn't the best adulting decision, but that's all right. Glad you're safe in here. Oh, was it? Did you find out?
Looking into it.
Okay.
They are looking to schedule an emergency classroom.
Okay.
Move everyone into.
Okay, so they'll probably call on that.
They'll probably call back in a second.
Okay, cool. All right, I'll keep going.
Yeah, no problem.
Thank you.
Anything else that I can help with since I'm here?
No, it was literally just that. Yeah, we're good.
Okay. All right. Well,
Thanks, Caleb.
hopefully that comes back on soon.
All right, you have a good one.
You too.
Did you find that, Gustavo? Are you on the right spot now? Okay, so they're probably gonna move us. When that phone rings, we'll probably go somewhere else. So is everybody following along? Just ready? Jump back in. Okay, so the degrees of freedom in the denominator are n minus k. So degrees of freedom error is 15 minus 3 is equal to 12. Does that make sense? Or where we left off? N minus k. Degrees of freedom error, 15 minus 3 is 12. Why? Because our total, we have 5, 5, and 5 in the chart, if you're looking. So the chart, I'll do this off memory. You guys tell me if I'm getting the chart right or wrong, but it should have been something like we had 3.4, 3.5, 3.2. But the sum, there should have been 5, 5, and 5. So n should be equal to 15. If you're looking at 12.2, 12.2, I can grab the textbook. We're not. No. Should be 12.2, which should be right. What you should be looking at would be something like this type of class. psych, soc, bio, like that. And then we have some numbers here. 371. I'm just going to draw it for you too. 371 in the paper. Table 12.2 in the text. I don't know off the top of my head which number it is electronically, but it's okay. I can draw it fast. 32654. 2654. 46546. So these are different means, mean one, mean two, mean three, because these are different sets of data. The actual, like the count is going to be N1, small n1, count small n2, count small n3. All the small n's, kind of like a sample, comprise the population for the large N. This is your, if we look at the means, this is going to be your between groups variability. Groups variability. Variance. And this is your within groups right here. This is your within groups. Variability. So like within groups variability. Everyone have that? Or does that make sense? This is table 12.2 in the text. So if you want to follow on your book, you can do that, or you can draw that. All I did was basically copy that. It's in line with the worksheet. So we talked about degrees of freedom error. So when we state the degrees of freedom for ANOVA, we always state the degrees of freedom between two groups and the degrees of freedom error. So we had, does everyone have this on this side before I? Okay. So we just did degrees of freedom between groups, and that was equal to 3 minus 1 is equal to 2. And then we had degrees of freedom error, which is equal to 15 minus 3, which is equal to 12. K minus 1, N minus K. That makes sense? Where I got those numbers from? So now we want to find our F statistic before we do anything with the F obtained value. So for this study, we then have an ANOVA with 2 and 12 degrees of freedom. Where do we get that from? 2 and 12 degrees of freedom. Or DF, degrees of freedom between groups and error. So let's look at our F table and let's find the F distribution. So you want to find 2 and 12. So you want to find like your row and your column. So as the value for K, N, or N increases, so for K, N, or N increases, any one of those, so too will the degrees of freedom. As the total degrees of freedom increase, the F distribution becomes less skewed, meaning that the tails of the F distribution pull closer to the y-axis. In terms of the critical values for the ANOVA, as the degrees of freedom increase, the critical values get smaller. Hence, as degrees of freedom increase, the power to detect and effect also increases. To locate the critical values for ANOVA, we'll use the F table, which is in table C.3 of Appendix C. The F table in Appendix C lists the critical values at a 0.5 and 0.1 level of significance. The values in the boldface are 0.01. To use the table, locate the degrees of freedom in the numerator listed in the columns, and the degrees of freedom in the denominator listed on the rows. The critical value is the entry found at the intersection. For a one-way ANOVA with 2 and 12 at a 0.05 level of significance, the critical value is 3.89. Did everybody find 3.89? Does that make sense? Did not just come out of the air. That is going to be our F statistic is equal to 3.89, which is literally our critical value. Everybody with me so far? Makes sense. So keep in mind that the F distribution is positively skewed. It begins at 0 and is skewed toward positive values. So the critical value for all tests is placed in the upper tail. Negative outcomes are not possible in an F distribution. It's just like F distributions work. The null hypothesis for an ANOVA states the group means in the population do not vary. The alternative hypothesis states the group means in the population do vary. 4 assumptions for a one-way subjects between subjects ANOVA are normality, random sampling, independence, and homogeneity of variance. The rejection region is always located in the upper tail of the F distribution, so the critical value is always positive. Ready for an example? Is that all making sense so far, everybody? So, example 1, employee turnover is a common concern among businesses and organizational psychologists. Stress levels at a workplace are often cited as a key reason for increased employee turnover, which is the rate at which employees leave a company, thereby impacting costs needed to hire new employees. As an example, in one such study area of this research, suppose we ask new employees at a company how long they feel they will remain at the company. Employees are assigned to groups based on how stressful they rated the workplace. 10 employees rated the company as a high stress workplace, 10 moderately stressful, and 10 as low stress. The time and years that employees said they would stay with the company are given below. We will conduct an analysis of variance to analyze the significance of these data at a 0.05 level of significance. And then you should have that chart, which should also be available to you in Excel. Does everyone see the chart? And I believe for Excel, I believe probably reference 3. It's probably like the most recent one. Reference 2, like number 3. Yeah, then you should have that. That should be your first. That should be your first chart. Sea levels, is that right? Let me see. 3.4, 0.5, 0.9. So everyone see the chart on the left. I'm going to walk you through where we get all those numbers from as we go through the worksheet, okay? You can certainly open up Excel, but I'll explain what those are. You can also reference the table on page 376 in our textbook, if you would like. That's like at least the original table. So step 1, state the hypotheses. The null hypothesis states that the group means in the population do not vary in variance, so that's 0. Alternative hypothesis states the group means in the population do vary, variance is greater than 0. And then the notation is H sub O, like for null, or mean is equal to 0. Group means do not vary between groups in the employee population. And then H subset 1, group means do not vary between groups in the employee population. Does that make sense? Should I write anything on the board, or is the worksheet clearly making sense? So the criteria for the decision that is the significance for this test is 0.05. The degrees of freedom between the groups are K-1. So degrees of freedom between groups is 3 is equal to 1. 3 minus 1 is equal to 2. The degrees of freedom are N minus K. 30 minus 3, not 30, is equal to 27. Does that make sense where all those numbers came from so far? Based on the chart. So locate the critical values for ANOVA. with 2 and 27 degrees of freedom, we're going to find the critical value for, which would be 3.35. Everybody take a moment, find the critical value. Tell me that 2 and 27 makes sense for 3.35. Back row. Jonathan over there on the left, makes sense. Yeah, so what you wanted, so we had, so if we look, so we have the degrees of freedom between groups is equal to 3 minus 1, which is 2. You know where I got this from? Okay, or on Excel, or on the worksheet, either one. So K minus 1. Now, why did we do that? Well, we have on the chart, we have pretty much sea level stress of workplace. So if you scroll up on the worksheet to the chart, you have low, moderate, and high. We have 3 groups. So we know, because this is also equal to degrees of freedom. Degrees of freedom, BG, is also equal to K minus 1. K is equal to the number of groups. So we can agree there's 3 groups, low, moderate, and high, in terms of quitting their job because maybe our manager is out of their mind. See, there's a story I can tell, but some of you gents like have heard it, so like I don't know if it's worth it. I can tell it for the front row, but yes, that does not work. The projector doesn't work. So they were just going to see about an additional classroom because it'd be helpful if I had the projector, but if not, I'll use the whiteboard.
Okay. Well, I'll have to look up.
Okay. And then maybe so they're going to call. I think they're going to call that phone on the.
Okay.
They're going to call that phone on a different classroom if they have one, so that's fine.
Okay, I'll come back later.
I think we go till 10 to 1.
Okay, sounds good.
Oh, I didn't see you on Zoom. Sorry. I've been recording. I just didn't see you on Zoom. We're in class activities. Today's date, chapter 12 deep dive. There's a worksheet and an Excel sheet. And we are roughly on page 4. Sorry. If you would have texted me, I probably would have known because of the projector issue, because the projector's not working. I put the phone on ring, not to like have it ring all 4 hours, but just so that they could call me. So sorry, I didn't let you on Zoom. I didn't know. And if your colleagues didn't see it, then they would have seen it and told me, I would have let you in, but I recorded, so you can certainly review that. So we are in example 1 on the worksheet, like I said, about page like 4 or so. If you want to tell me when you're there, or if you're not able to find it, just tell me, or maybe you can help Lex since you're right there. Okay. So then if K is equal to the number of groups, degrees of freedom error is the same as N minus K. So can we agree that there's 30? Does that make sense? Does everyone know where we got 30 from? Except for Katie. You'll be able to catch up in a moment. Because we had 10, and 1 is 10 on that chart, and 2 is 10, and 3. N1 plus N2 plus N3 is equal to N. I mean, this could be N4 and 5, it wouldn't matter. It's because we have more than 2 for the ANOVA. Does that make sense, Jonathan, over there now?
Yeah.
So that's where I got the 30 minus 3, 27. So now we have 2 and 27. So now we want to find a critical value of 3.35 in our F chart. Does everyone see the critical value? That critical value. 3.35. That's our rejection region for the test. Went into your F chart, that should make sense. So we're going to start with just some real basic. Okay, so then compute the test statistic. So all we're doing is we're just seeing if the degrees of freedom make sense for the F obtained value. We're going to get into the more involved math in a moment. So all we're doing is we're going to say F obtained value is equal to the mean square between groups over the mean square error, which is effectively 2 divided by 27, which is 0.74 or 0.074. Sorry. Therefore, in this case, we retain the null hypothesis. Does that make sense? Yeah. Right now, it's going to get more complicated, but I'm going to walk you through it. This is just the basic step. Don't let that statement freak you out. We will get you there. Green, Anisha, Katie, everybody, we will get you there. Does that make sense what I did? Just the basic steps. The 2 over the 27 and what we got 2. So I have a second set of data. I do not want you to go, I don't want you to do stage 1 or anything. I want you to go directly below the chart and just do the same thing I just did. Find your F statistic on the new set of data with the n equals 12 and find your F obtained value with just that basic math. And follow the steps above. I'll give you 5 or 10, and then we'll walk through it as a class. Yes. Don't touch that yet. Just work with the first part. We're gonna walk into that like probably by 10 o'clock or sooner. And then the Excel sheet that I have will make more sense too. Do you have a sense of what you're doing for the steps? Okay, I'll come around and check. Yeah. But your numbers are going to be different, right? Because and all the ends in the case are. Right. Our 6 will still be 3. So there's 3 of them. We're gonna walk through 12 a whole bunch, and then 11, and then 3. And the attached worksheet, because I've already done all the math, even though the projector will be okay today. Do you sense of this? Don't do yes. Just the way I should. We're gonna get into the calculation in detail.
How you doing?
Okay.
So all we're doing is where you do program to achieve that. Excel, you don't even need Excel yet. We need Excel in a moment. But we're just gonna find out what's K, what's N. Based on that data. So, you know what it says, so when it says there's different ways for stages, don't even worry about that. Just do, I found my F statistic, it's this and this, and then divide the numerator by I'm gonna walk us all through it in a moment, but we're just doing, so we scroll down. So it's just from there, step 1 all the way through step 4, but it's like that. So when you get the 0.074, so it's the second. You show your work gets that. So don't, when it starts saying there are many different ways, don't even worry about that. I'm gonna walk you through that. Just do the 2 or 3 steps there directly above it. And you will have different numbers. Like your N is going to change, obviously. K is going to be the same. Because there's still 3 groups. Yep.
That ever happens, like Wednesdays, we only have 1 more meeting, call this number, that'll bring that phone.
Oh, okay.
Because I really would have loved to let you in. I just didn't know.
Because I was driving and I couldn't like just stop.
I wouldn't want you looking at anything. I would only want you to be hearing my voice if you were driving.
And
Just for safety.
yeah, right.
Like, I don't want you, oh, she crashed into a tree because she was doing stats on her phone. No, that would not be good. I'll give you all a few more minutes to work through it, and then we'll walk through it as a class. Okay.
So she kind of like associates it.
Gotcha. Okay.
Perfect.
That's just
That's your.
So there's 10 values in each one of those. So all those together would equal 2. And 1 plus 2 plus 3 4. So all your small ones for your life.
So the formula for FMT is MS will be greater than MS.
Yep.
But we did find it 0.074, which is divided.
Yeah.
So it's the same thing.
Yeah, we can do, depends on what, yeah. These are. Yeah, this, we take this divided by this. I'm gonna walk through all of this in detail. We're actually filling a much bigger chart. But yeah, all we're doing right now is this divided by that. Period.
Period. Sorry. I'm trying to say period, but then I sneeze.
It's all right.
Period.
I get like these violent sneezing attacks, but I could probably sell in a small ice cubes and they would like it. That's the curse from my dad. He's like 70, the most good salesman. So like if I ever need to eat, I could just sell random stuff. I didn't want to do that. That's why I went to school forever. So it's like it's great because I have that, but also sneezing with the allergies where I'm like, oh, that was, and I had to completely say the full at chew. Just frustrating. People usually tease me for that, but at least I won't starve to death. I mean, I guess it's a first world problem, right? How's everybody doing so far? Still working on it? Need a few more minutes? Front row, back row? Okay. Don't worry about the next steps, super complicated, but we're gonna walk through. It probably does, but there's Excel sheets. Right. If you talk to the Excel sheet and we're documenting, they don't give me a classroom. For the projector, this is okay. I spent a lot of time on this worksheet, took me several hours to develop, but it makes it really, really simple. For the first one, is 0.07.
It's the next one to be close to.
The next one's probably pretty close to because that didn't change a lot, but it will be the same number.
Okay. Yeah.
I don't know the number. These are my worksheets, so I don't actually have an answer to these, but I can walk us all through the steps. Which in a previous class, student was like, I like to know that some of your students have answer keys. And probably so we actually know the steps. So. All we're doing is we're doing increase freedom between groups. Increase freedom error. Number. That's probably pretty close to 0.74, 0.074, but it's not going to be the same. So your K minus 1, so minus 1 is at 32, then a minus K would be 36 minus 3, which would be 33. So what's K? 3, because there's 3 groups. So 3 groups. And then n minus k. So n is going to be all of your n1 plus n4. So which happens to scroll down. It happens to be 12 for all of them. Because there's 12 values. 12 plus 12 plus 12 is 36, which gives you your n minus k, which is 3. So 36.
Not the dark one.
Which is 33. So now 2 and 3 give you your f. So wherever that is in the chart. So that's your f of t value that you calculate. Look at the chart. The chart. Statistic. And like in the book or the z-score table that I put in chapter 6. Resources. Chapter 6, yep.
Yeah.
And then scroll down to you get to the F scores. That's it. So our first one, we have 2, yes, and then so 2 and 3.
Two and 33, so it's the one that's
And then
not.
you say it's.
3.28. Yep.
Rejected, and this was not.
And then as we go, so if it's like 80, it's 25. It's 0.5. If you scroll up to the top of your chart, not only the top, just. Okay, go back. So, like, that's that. Top of the page. Up like half an inch. Stop right there. Perfect. Critical value, 0.0506 gets light face type. I said 0.0506. That's why it's the 3.
Yeah, so you compare it.
So
So
it's
the
2
number,
and
the critical
33.
value.
That's the light. The reason 0.05.
And so imagine it like on a
Makes
chart,
sense,
right?
right?
That's really good overview.
Now,
And it has to.
divide your 2 divided by your f of pain value, and then compare the two, say if we reject the hypothesis. 2 divided by 33, yeah. 0.06, yeah, that's perfect. That's the cutoff, so we're gonna retain. I'm gonna walk through it. Okay. We're gonna do stuff, we're not gonna do stuff anything with that yet. That's the moment. But- I'm gonna walk you through what we do with that in Excel in a moment, and an Excel sheet for you all with the math and the answer statements. I'm just saying, degrees of freedom between groups, by the degrees of freedom error, and it's doing that manually, just the fraction. And then, where I start saying stage 1, I'm gonna pick it up. Everybody in a pretty good spot or so? So the F obtained, first we want the F statistic. So degrees of freedom between groups, 3 minus 1 should be 2. 36 minus 3 should be 33. So we should have 2 and 33. So if we look at 2 and 33, we should have a critical value that should change. We're using 0.05, we're using light face type, so I think that was 3.28. So that'd be 3.28. Which would be our F statistic. F statistic. Statistic. And then our F obtained value is literally just taking 2 over 33, which I think you get 0.06, which means we're going to retain the null hypothesis because it was not at the rejection region or beyond it. That's it. 0.0606 or something, I think. Approximately. So then you compare those two, it's inside, we retain the null hypothesis. Now, when you're ready, let's jump into the more complicated stuff. So we have to do the preliminary calculations. But first we need to do some stuff. So if you go into Excel and look at that table on the far left-hand side, and I'm going to explain what we did in that table. The third one, the third Excel sheet, I think is the most recent and most current. And I think that has all the answers, but you have to understand what the answers are so that you know how to get there on the test. Does everyone have Excel open? Take a moment. I think they all work, but I think the third one is the best. And if it'll make sense, I'll write it on the board. You guys want me to write on the board too? That'd be helpful. Like how we got there. We need a pretty big table. Okay. So we have perceived stress at the workplace, right? Perceived stress at the workplace. Things that might drive that, the toxic organization I used to work for. It's my review for some of you Gen Psych students. We had this company that would take us to Vegas once a year on a sales conference. Which is awesome. It's Vegas. So my coworker, different team, she saw her manager snort a line of coke in Vegas. That's important for the story later. So she got called out for not producing. She got called into a conference room with her manager and her director. And the manager was the one that she saw snort a line of coke in Vegas. And they were like, well, where's your production? So she was like, shut up, you effing cokehead, to her manager. So her manager pushed her, she fell backwards, got up, roundhoused or punched her manager in the eye, gave the manager a black eye, and then the meeting abruptly ended. In terms of perceived stress at the workplace, she calls HR and tells on herself. I'm like, well, we're going to investigate. So they call the manager and the director down separately. And the director says, never happened, I was in the room. And the manager says she fell at home. And the day went on and no one got fired. You see the level of stress of the workplace might drive some of these numbers. True story. Totally probably like assault. They probably should have like called the police or something. But that was that. I don't think she'd make it up. I wasn't in the room, but that's how she told me it went down. I think that's probably how it really went down. So yeah, bad place to work. And I worked at 30 organizations on LinkedIn, so good luck figuring out who that was. Okay. Anyways, so our chart should look like this. We should have low, moderate, and high. K is equal to 3. And then we should have some numbers, 3.4, 3.2, 3.
Can we read them off to you?
Could you? That'd be wonderful.
3, again, 3.5, 3.8, 3.6, 4, 3.9, 2. Are we doing of the squared or not yet?
I'm going to do those in a second.
Okay, so for moderate it's 3.5, 3.6, 2.7, 3.5, 3.8, 2.9, 3.4, 3.2, 3.3, 3.1. 2.9, 3, 2.6, 3.3, 3.7, 2.7, 2.4, 2.5, 3.3, 0.4.
Okay, perfect. This should be the chart that we're looking at so far. Now, so we're going to agree that N1 is equal to 10 because there's 10 values, and 2 is equal to 10 values, and 3 is equal to 10 values. So what's N? 30, right? Makes sense? 30, back row. Did you hear my story about the cokehead? Okay. All right, great. Just making sure you guys are paying attention. Awesome. Okay, cool. All right. 30, K. Okay, perfect. And K is 3 because we have 3 groups. So the next thing we want to do is we want to sum. We're going to have the sum of the values, sum x1, sum x2, sum of the values 3. So you should have on Excel, you want to read them off to me? 97.1. Is that the sum? 34.3. 34.3. 34.3. All of these sum together 34.3. All of those sum together 29.8. I'm pretty sure.
For moderate is 30.
34.3,
Oh, yeah,
33, and 29.8. This is 33, and this is 29.8. All I did is I put values like that, and I sum them together. Okay. In terms of the level of perceived stress. Or the stress I have when I got in trouble for not producing when I was in the office, and I had to decide whether I would hack the system with the software and get a lead to roll to me, or not, or lose my job for not producing or violating company policy. I chose to violate company policy. Manager gave me the lead switch, not unethical, just a violation of the rules of engagement in terms of the distribution of resources, different things. That would be like calling on a phone, that phone for a personal phone call.
That phone was-
That would be like against the rules, probably wouldn't lose my job, but violation of the resources. That's the nuance. It wasn't unethical. I was still helping the person. I took away from a different salesperson because I don't want to lose my job. Level of stress. Okay, so we sum those. Now, let's go ahead and square them. So we're going to take all these to the second power to the right. So the first one should be 11.56. It's to the left. Can you read those for me?
Oh, it's to the left.
So the first one's to the left, and then the other two are
Yeah.
to the right.
Okay.
Yeah.
10.24. 9. 12.25. 14.44. 12.96. 16. 15.21. 8.14.
So this is so we just squared these. Now we're gonna square these.
12.25. 12.96. 7.29. 12.25. 14.44. 8.14. 8.41, I'm sorry. I know.
It's all right.
11.56. 10.24. 10.89. 9.61.
And last, so this is another square, okay? And then we're gonna square these. And what do we have?
8.41. 6.76. 10.89. 13.69. 7.29. 5.76. 6.25. 10.89. 11.5.
Everybody with me so far? We took our values and we squared them to the right. On the Excel sheet, this happens to be over here. It's the only difference in the Excel sheet that you're looking at. Now, let's sum. Let's do some summing. So first, we're going to take and we're going to sum our values, okay? Which is going to be equal to sum of the values total, which I have 97.1. Does everyone get that? Just all these values on the bottom, sum them. Now we're going to take and we're going to sum all of the squares. So we should have 97.1. Sum of the squares. And what else? Do you have the next one? Or I can look. 97.1. No, what? No, it's 119.
Yeah.
It's 119.07. Yeah, it's 119.07.
And then 109.
109.9.
And then 90.5.
Does that make sense, everybody? Where we got those numbers from? And then the last thing we're going to do is we're going to get the sum of the values squared total, which should be 319.47. And all that is that's summing square, 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 that number. So we have the sum of all the values like this, the sum of all the squares like this. Does that make sense, everybody? It's also in Excel. That's what you're looking at. If I lost anybody, all making sense so far? Okay, so now let's find K and N. How many groups do we have? 3, so that would be K. We can all agree that makes sense, right? K is 3. And we have 10 participants in each group, which is 10. Let's find the sum of the values and the sum of the total in each group. We just did that, right? Let's find the sum of the squares and the sum of the squares total. You do that? Sum of the squares, yep, sum of the squares total. We have that. Square each score and then sum of the scores. We did that. We did the sum of the squares. Intermediate calculations, find 1, 2, and 3. And then there's 3 calculations. First, we need to make a calculation for 1. What is 1? These are our intermediate calculations. So one is always equal to the sum of the values total divided by n. Do we have that? 97.1. Oh, we can do the correction factor by squaring. So we're gonna square that. So 97.1 squared over 30. Makes sense so far? We should get 314.28. That's intermediate calculation 1.
Is that calculation on itself?
It's on the worksheet. And there should be a square. So I think I don't think I think the worksheet is missing that. Just make sure you have the square. Back now, it's bothering me, so I'm probably gonna add the square. Edit. Browse. Okay, I corrected the worksheet. So now if you download the new worksheet, it'll say that. Well, okay. Second, so 2 is calculation intermediate 2 is the sum of x squared over n, which is going to be equal to 3430 squared plus didn't think it would be that angry with itself. 34.30 plus 33.00 squared plus 29.80 squared, and these are all going to be over the n, which is 10. Does that make sense? For calculation two? So like this is kind of like spread out because it's these different sums. Okay. So we're gonna take, so we're basically gonna like be doing this, and then we're gonna square them. And we broke it down because we have 3 different ends. If we had 10, it would be 10 of them that way, N1, N2, N3. So this should equal, if you do your math, make sure it's numerator by denominator. You should get 315.35.
You can't just do like all of those square values divided by 30, like that's the individual.
I believe that that math should actually still work.
Yeah, just do the 34.30 square plus 33 square
Plus-
29 square divided by 10.
By 30. Because you want to count for the numerator, the denominator. I like it like that, but I'm pretty sure if you do this, plus this, and you get like a total over here, and then you make these 30, that math should still work. Yeah, that should still work because it's the summation on the top and the summation on the bottom. So that should still work. Does that make sense so far, everybody? Does anyone need a moment to catch up on the math? So third, so then we do number 3, which is, can you all see right here? Or should I be up further? Okay. And you can see over here, ladies? Okay. So the third calculation is literally, we're going to restate the sum of x squared total is what? Well, I think we have it, don't we? 319, 19.47. We're just restating that. Make sense? Three is equal to the sum xt, and we already have that. Sum x is equal to 319.47, and that comes from this, which was the sum of all the squares. Make sense? Okay. So then we can use the values to compute the sum of the squares for each source variation in the ANOVA. Are you two okay, or do you want me to? Okay. So sum of the squares is the numerator for variance chapter 4. Hence, the calculation making stage 3 will give us a numerator for the formula for this variance for the source of each variation. Stage 3, computing the sum of squares for each source of the variation. The sum of the squares between groups is the difference in the calculation between 2 and 1 in stage 2. So the sum of the squares between groups is equal to 2 minus 1. So 2 minus 1. So that means that's going to be 315.35 minus 314.28, and that's going to equal 1.07. 1.07. That is the sum of the squares between groups. Then we're going to do, does that make sense before I do another step? The sum of the squares total, which is equal to 3 minus 1, which is equal to 194. No, that number is not right.
where's three? 319.47 minus 314.28, and we should get a different number. 314. So this should be equals to 319.47 minus 314.28 times 314.28. So I have a number 5.19. Perfect. No, that's right. 5.19.
That's 5.19.
Yep, that's right. Save. I'll update that right now. I'll just go in, edit. Mark. Browse. Open. I just updated that, so if you download it again, it'll make sense besides what I'm writing on the board here. So then the sum of the squares error is equal to I did it twice. And that's not F, that's T. The sum of the squares error is equal to the sum of the squares total minus the sum of the squares between groups, which is equal to 519 minus 1.07, which is equal to 4.12. Yep. Stage 4, completing the F table. The F table lists sum of squares, the degrees of freedom, and the mean square for the value of the test statistic. The calculations shown below. So you should see the table. So you should have the sum of the squares between groups 1.07, within groups 4.12, total 5.19, and those all add up on that column. Degrees of freedom, K minus 1 is 2, N minus K is 27, N minus 1 is 29. And then we have the mean square between groups, which is the formula for the mean square between groups is mean square between groups is equal to the sum of the squares between groups, over the degrees of freedom between groups. And then the mean square error is equal to the sum of the squares error over the degrees of freedom error. Which we have. So if we plug in the sum of the square, so to compute the mean square between groups, sum of the squares between groups divided by degrees of freedom between groups, you should have 1.07 divided by 2. Does that make sense where I got that from? Sum of the squares between groups right here equals 1.07 divided by 2, which is equal to 0.535. This next one is to compute the variance or standard mean error. We divide the sum of the square error by the degrees of freedom. So that's 4.12 divided by 27. Is that right? Mm-hmm. And we get 0.152. Right? Makes sense? 0.152.
Yeah, 0.152. The formula for the test statistic is the mean square between groups, 0.0535, divided by the mean square error. So the last formula we're doing F obtained value is equal to, oh, that was lovely. Did it just disconnect? We'll do that. Okay. So that's the mean square, between groups divided by the mean square error, right? Yeah, mean square error. Mean square error, which we have, mean square between groups, 0.535 over mean square error, 0.152 is equal to 3.52. 3.52. The asterisk means that's the decision to reject the null hypothesis. Why? Because it was greater than the critical value. By looking that up. So we make a decision, we compare the obtained value to the critical value. The obtained value 3.52 is greater than the critical value 3.35. It falls in the rejection region. Now do the same calculation using the steps I just showed you. If you go into Excel and you scroll over to your right, you need to create your own table, but I did all the squaring and all the adding for you. So let's take 5 or 10 or 15 to do that. Yeah, you can use Excel. Just make sure you do the formulas right way. You should probably write it out in Word or on the paper. Take a picture. That's fine. So we're gonna do all these, sum them, square them, do 1, 2, and 3. Do this, do that, and fill in your table. Different numbers. Make sense, everybody? And then we'll do it as a group. But just like in terms of learning, walk through that. Excel has that. Now, the table at the bottom is not the right, you're gonna have to create your own. So we see like source of variation, I'd probably just cut and paste it somewhere in Excel or onto a Word document, clear that all out, and then start filling stuff in. And then, like I said, I'll walk us all through this in a moment. And I'll come around to make sure it's all making sense for you all. What? 3 groups of 12. Scroll down on the worksheet. I changed the data. So this is going to come out slightly different. But if you go to the Excel sheet, like I'll come around.
Yeah.
I'll come around. So if you go into Excel. Go ahead and classic theories. And then click on the reference one. So the source, so this table, you're gonna need a blank one of those. Like copy that, but then delete everything. Perfect. And then just delete that. Yep, so it's this one on the right. So that one, so those are your, so I squared all those for you. And then I summed those, and I also gave you your sum of your values. I gave you a lot of the stuff to check. But now, the steps on the board, your numbers just go
step by step. That makes sense. You have the sum of the total, you have, then you have the sum of all the totals, and then you have all the squares, and you sum of those squares, which is all written out for you. Save it. Yeah. And then after you all get the fresh shot and it's all done, then we'll do step by step. That way you learn. So. Because if I just walk you through it all the time. Now, you should absolutely check my math, but if you go into Excel, that the chart on the right should already have all the information for you, but it would be a really good idea to work through it and know how you got there. You can work based off that one because a lot of the preliminary squares and addition I did for you to save you a little bit of time. As long as you know how to get there, because obviously those blanks, those are all squares, like all to the right.
Yeah. This is just where, this one.
That's squared, yeah.
This one is-
Yeah. And like I said, you can spot check my map, and that should all be correct. And then some, well, I've been in this worksheet like for several semesters, so it should all be
Yeah.
correct. And then I keep saving it over itself, so. The 97.10. Wait. Sum total of that. Yeah, because it's yours for it.
This first row, this is the second square, just, that's just labeled, that's just how you labeled it.
So this is a better chart.
What you're doing.
These are all to the right. So the sum of all these. And with your. So 7, 8, that's that. Those are right here. And 7 and 8, yeah, that's those. So that's. Yep, those are all those pieces. And then this should be the squares on the first one. Yeah. This right here is the sum of all these squares, and I just put it in. So I can label that the same. This right here should be the sum. Is some of the totals. And then the squares, the sum of the squares right here, x2. The sum of the second value squared. And this is again all those and then the squares, which is 114, and the sum of all the squares total is 1.95. So then you probably want to do, so some of the others is take this table or just blank it out because these are the answers for each. Or keep those so you can have them and just like cut and paste like in a spot of Excel and then just clear out those and go through those. Yeah. And then the source of variation, that's from the last example. So you're going to create your own table based on the data that's there. So I did all the squaring and summing for you all. Then we'll just I'll walk through all the steps. Everybody, but you just not going to be works unless you all attempt to try to get the answer first. Okay, so that makes sense. So like you can keep that one up and or you can cut and paste the
Very sorry, you know.
I usually close it if there's a lot of background noise.
Yeah.
Just people are walking by or on their phones. But I hope it's not locking from the outside. 'Cause I'm not trying to lock anybody out of the room.
Yeah, that's why I left it open, because I was like, I don't know if it's gonna lock.
If that ever happens, like wave at me or
Yeah.
something.
Oh, you just.
Still doing all that stuff. I'm just trying to give you Excel to make it easier. So you know how you're getting there. And if you look at table 12.5, that could be helpful potentially. Does that make sense? But another reason you would take this class is cognitively healthy. I was dealing with something last night for a client, right? I did a PowerPoint for a diagnosis. All those transitions are nice and pretty. Well, except format. It's in the right format.
No.
So I take it and I make it PDF. This is that format too.
Yeah.
Because there's too much information behind it. So then I exported it to a Word document, and it still wouldn't accept it. There's code behind like, all the information. So then I cut and pasted it with notes, which gets rid of all the crap behind it because it's kind of like three-dimensional in a sense. Then moved back into Word. Then I had to save it as DOCX file because the DOC file wouldn't read. And then I took 60 slides and I compressed it into about 5 pages of the same exact material. Made the file much smaller than I found. It took like 20 minutes to figure out that like exercises like this are what help you solve real world problems. What? Cumulatively? Like this? Yes, because this is all additions of the numerator. And do not, so what you're doing is you're taking this and dividing, taking this and dividing. So if you take all this cumulatively and all this and divide, your answer should still be the same. Then do it the way I showed you. Period. Then just do it. I know that's extra steps. I know. That was kind of like a meme there, Annie, with the facial expressions.
It doesn't make sense that why it wouldn't work.
I feel like it should work.
I got a nice
It has to be a positive number.
for the SS error.
It should all be positive. Because it's F obtained value.
Then wait, in my. The step 3, it's just your EX T value.
EX squared T value, yep.
Which was 372.95 for.
Probably.
What about?
That should all be correct.
For one? 65.4?
And that makes sense because that value should be a little bit less. That makes.
Oh. Oh.
K is equal to 3.
Where are you talking? -1? Do we have that up here?
There's 3 groups, so it'd be 3 minus 1 is 2. Your K would still be 2. Because we still only have 3 groups. Does that help, Annie?
The squares over 12. Like the one that he puts like
2 minus 1. So 2, this, which you would have calculated, minus 1, which was the sum of the total squared divided by n. So this would be 36, and the sum of the total n would be something like 114.7 squared. And then you subtract those to get a number that should be a little bit less than whatever your total was, which I think was 372. Did I totally lose you? I'm not trying to. So
oh, I'm squaring.
when I say 2, it actually has to do with like the steps in the book, like is that 2, that 3, is that, so I see the brackets. Those things, and then this right here is basically that we just looked at, and then this is what we just got to, and then we're basically just working backwards to all our values, we square over the sum of 2 minus 1, so this, whatever this answer, 2 minus 1, whatever 1 was. So that's why we got. Absolutely, why we meet face to face. So what I think we'll do is give you 2 more to work on the steps. And we can ask exercise, so give you 2 more tips on 12 once it's done. Then we'll take a break, do much easier work on 12, much easier work on 11, and then if we have time, we'll start with I have a worksheet for you all. So that it's really, really clear, and then whatever's left over, we'll do that and then reviews on Wednesday. And you all should be going with the plan. Want to remember where the J's are because I think we have time on the exam. And you can walk yourself through the formula, and if it takes you a long time on something like this, it'll be okay. But as long as you know where to go, find the solution, that's fine. It could make the class really difficult, and like you all memorize everything, but I don't think that would be fair.
Do other stats classes like have an in-class class?
Oh, yeah. And
Are you kidding?
when I taught at Dominican last semester, and apparently they got pissed off at me for saying we're 45 days, because I thought that was so cool. Truth, and I wasn't being a jerk about it. It was just like, this is what this is. Like, I'm standing up for myself. Like, please get it together. I've got a school over in Virginia teaching statistic classes, and it's hard. They pay us at the end of the class. Appreciate it. First, I want to know what our pay is for. So my boss is talking for us, they're still paying us at the end of the class. It's just like you work for free and then you get paid at the end. But at least they tell you what the date is.
Yeah.
I can live with that.
Yeah.
I told another one of my bosses I appreciate the bean counter every year, looking at my classes and then telling me where I. She created a gallery in the top. She made up of all of us. Now they full-time faculty actually told me part-time faculty, which is how it's supposed to be always.
But they created like an online gallery that I set up through, but she didn't give me any classes for like 3 or 4 months because it's called a spade. Now I have my contract back. I wasn't a professional or anything, but I was like carrying the truth. Yeah. Most schools pay me every 2 weeks, most of them, because that makes a little more sense. But that was absolutely close book, closed note, and I had a lot more students not, well, there's also research methods on top of stats combined.
Okay, well, let me know.
So that's definitely harder because they had to do a research project and learn all the stats and the formulas. And it was closed book, closed note, and it was on a computer, but I had to walk around and walk through, make sure they weren't cheating, which every year the scores go up and some of the other faculty are suspicious of cheating, but the tests aren't the same, like it's hard to do. And some of the stuff they're asking is harder than what I feel if you, in terms of assessment outcome, if you spend 5 hours looking stuff up and teaching yourself the steps again, you get it right ultimately, that's still an assessment of your knowledge.
Yeah, that's very sure.
So, because of philosophy, there's so many close book, those no, I'm not looking to make your life's hard, I'm looking to help you understand it and know to get there. And if you're in the real world, you probably could look at the formulas and be fine.
Right.
They're not gonna be like, we're gonna lock you in a room and figure it out for 3 hours, and you don't come out with an answer, you're screwed. That doesn't happen in the real world. Just like grading rubrics. Like, that's great, because you have criteria, but in the real world, you're not getting a grading rubric. It's not a thing. Either you did the thing or you didn't do the thing. One of my colleagues at a previous place used to always fight with them about grading rubrics, because he's like, it's sports. It's like sports psychology assessment. It's not even a thing. So he wouldn't do it, and then they would mad at him all the time for not doing it. It doesn't make sense. I just want to see if they did the thing. For me, my grading rubric's very simple. It's kind of like baseball. Like, hit the ball. That's a C. Hit a home run. That's a B. Knock it out of the park. That's an A. Like, that's pretty easy. Like, just do a great job. Like, I expect command of the language to be right. I expect things to be articulated clear. I expect the steps to make sense to get the right answer. That's it. But it's kind of jacked up because it's K through 12. It's like if you're average, that's a C. If you're above average, if you're like doing better, that's an A. I don't know if that's always the best assessment, because what if you're not being taught well? The average kid could be the A student.
Yeah.
And sometimes there's curves, like where they grade on a curve. But yeah, they actually, I had a lot of students that struggled at Dominican because of the testing conditions. I could be about it because it was set by them.
I know, I was gonna say, I think that doesn't matter.
Academic freedom varies. Here I have complete academic freedom. Everything that I know.
Wait, Dominican,
Kid University.
yes, the
No,
place
no,
you
no,
went to.
no. I have academic freedom. I can, as long as I teach you the content, I can teach whatever I want, and I can do, and I can administrate the test whatever I want. Most places you have a lot of academic freedom, but that class is created by my boss over there, and it's what he wanted to talk, which is fine.
I don't know.
That's why we could go outside last semester.
That was fun.
Academic freedom.
I like that.
As long as I just can't like
Wait, 2-8?
talk about politics for
Oh, then it would
40
be-
hours, and that would be a problem. I'd probably get complaints, but as long as we fill up the content, I tell you anecdotal stories to lighten the mood, it's fine, we're still covering content.
I got my. It was about-
All right, so we're getting some scores, all right, so we can work together here.
Right?
I don't have an answer key. We're gonna figure it out together. If we've all done the steps right, you're probably correct.
Where did you get your?
How are we doing? You go in at 15 or just working through it? Okay. If we're good, we'll walk through this, then we'll do some SPSS, then we'll take definitely. I'm assuming if you guys are visiting, you got to the F score, or at least close enough for horseshoes and hand grenades. Yeah.
I put another decimal.
So download number 3, there's
Yeah.
3 different Excel files, download the third one.
Maybe
The
that's
third one
fine.
should be pretty clean.
Yeah, I just found it.
In Blackboard,
I don't
exam,
know.
the
I
third,
honestly, I don't know.
chapter 12, that's the one I showed.
Is this computer not working? Like, I was
Yeah, so you
picking
can
it
download
up,
it on the
and
web.
then I was doing-
Let's go ahead and
So
go
then I was
through
like,
it.
well, I'm not gonna.
Yeah.
over here. And then
All right, you guys ready to go through it? Maybe we can check answers with the math. It should all, it should all make sense. If anything seems a little bit off, let me know. So so degrees of degrees of freedom would be k minus 1, which would be 2 for our chart. N minus k would be 36 minus 3, which would be 33. And our total would be 36, right? Just for like that middle column, that's pretty easy. Okay, so let's do the math step by step. So first, we should have the sum of the total values, which I believe I wrote down, we should have 114.7. Does that make sense where that came from, everybody? 114.7. Okay, then right, x squared. Yep, and then x squared. The sum of x squared total, you should have a different number right here. Just restating that. Sum of x squared total. That should be 372.95. Does that make sense where that came from? 372.5, okay. Does the math make sense with Excel? Nothing's wonky. All right, so then we're gonna take 1, which is the sum of this squared. So that's gonna be 114.7 squared divided by n, which is 36, right? Makes sense? What number do we have right here?
365.4.
365.4.
145.
0.45.
Yeah.
Yeah, we can do hundreds, that's fine. Now, generally speaking, this number should be lower than this number by end of this. So chances are you did the math right. So the next thing we're gonna do is we're gonna do 2. It's fine. So this is 12, right? This is 12, and this is 12, and then our sum of the sum of the squares. So that should be 40.1, right? 39.1, 35.5, right? Does that make sense? And we should get a nice number here. What do we get? $366.42. Seems about right. And then we're going to just restate this for number 3, which is 372.95. Everybody with me so far? It's all making sense? So we can move this over here and we can just write 372.95. All right, sum of the squares between groups 2 minus 1. This should be different. What's 2? This was 2, right?
Yeah.
So 366.42, right? So 366.42 minus 365.45. And what do we get? 9.9.
0.97.
1.97.
0.997.
0.97. Okay. 0.97. Okay, great. So that's that. 3 minus 1. 3 is 372.95 minus 1. 365. Is that right? 0.45. What do we get? 7.5? Okay. 7.5, okay. And then our sum of our, so that's the sum of the squares between groups, sum of the squares total, 2 minus 1, 3 minus 1, sum of the squares error, sum of the squares total, which we have 7.50, right? Minus sum of the squares between groups, which we have, which is, why is that negative? That doesn't make sense. 3 minus 1. Makes sense. 366. Yeah, there we go. 7.50 minus 0.97 is what? 6.53. And that is our sum of our squares error. Perfect. So then let's do this part. Sum of our squares between groups, 0.97. Difference of the square between groups. Yeah, divided by 2. You're right. Divided by 2 is equal to 0.485. And then sum of the square error is 6.53 divided by the degrees of freedom error, which is 33, right? Divided by 33. What do we get? 0.198. And then the mean square between, so the f obtained value mean square between groups is equal to 0.198. 2.5. And did we ever look at this, the F statistic? I don't think we did. It's okay, we can still look now. The F statistic is what? Should be 2 and 33. 3.28. 3.28. Reject or retain? Retain, yep. Yeah. Retain. That is it. And then you can fill in your chart accordingly. Get our F obtained value. We got our mean sum between groups, our mean sum error. We have our sum of our squares between groups and within groups and our total. And then of course, this and this always equal the sum of the squares between groups and the error of this plus this one always equals the total, which it does. Sum of the square between groups and error equals total. And that is almost the end of the worksheet. Our last thing is SPSS. So we're about halfway through SPSS and then break. Make sense, everybody? SPSS and then break? Or do you break? Okay, so let's open up SPSS. I believe we're doing 12.9. I might need the book back. I believe that's what my worksheet says. Because I don't know if I remember what 12.9 says.
What's the point eight? Like 4 what? 430 what? Are you
Hang on, I'm gonna look it up. It's whatever.
Page 389, I think.
I think you're right.
12.9.
12.8. 12.8. 12.8. So open up SPSS. Yeah, 12.8. And then we need to put the information in. Now the Excel file that I gave you, you should be able to copy and paste. But the problem is, you're probably going to want to hide some of your columns. So if you click at the if you click the letter, I can come over and show you and you hide. You should be able to just, you want to hide all your squares. And then you should be able to cut and paste it directly into the data on the first group.
So the
N equals 10. And then if you change your decimals to 0, and then you can label it on the data view, the very low, moderate, and high. I don't think we're getting the other classroom. I'll come around. I'll come around and I'll show you the steps on SPSS. Let's start with just getting the data in there. There's only like like 7 steps. So I'll just come around and help you guys. So it makes sense. So you can enter them in.
Yeah, I do it like that.
So yeah, so then click on variable view. And then change the name to low, medium, and high. Or moderate. Moderate.
Do we still keep it?
Yep, keep it at 0, just moderate. And then high. Go back into so go into Excel. So you can,
this one.
it's this
Yeah,
that
you
one.
just copy the row.
So just copy the row. You don't need the N is equal to 10. You just need the numbers. You just copy the rows one at a
Paste it
time.
as each one goes.
For each one, that would work too. Or just do file new. File new data. Yep, and then just, and don't paste low. Repaste that again with just the numbers. File new. Or I'll show you an easier way to do it. You go back into Excel. Click on your square column. Just click on like the letter B. Click on that and then right click. And click on hide. Now do that for all your squares. Hide. Hide. Now cut and paste just, yep, Control C. No, don't. Don't worry about it. You don't want low in there.
Yeah.
So click escape on the keyboard. Okay, now just highlight, yep, Control C or copy. Now go into a new SPSS file. Wherever your SPSS is, maybe close SPSS. That's okay, it's just still work on the clipboard. And then go to your variable tab and change your decimals to 0. Okay, so now for the variable tab, where it says variable 001, you can label that low, moderate, and high. You can say medium if you want, Alexa, but the chart says moderate. Like as long as you know what you're looking at.
Okay.
And then what you can do, click on the letter B at the top there. Click on hide. Now do that for all your others. Go for D. No squares. Hide. Now do that for the flat for F squared. F, yep. Hide. Now take and just highlight just not the low, just from there
Yeah, so just like left click. Left click and highlight. Yeah, there you go. And not just the 3.4. And then you copy it. And then go to SPSS. And then paste. Now click on variable view. And you can see where it says name low, moderate, high. Not where it says numeric. Low, moderate, high, and then make your decimal. Yep, got it. And make your decimal 0. Yeah, it's that one, and then go to variable view. Yeah. And make decimal 0. Okay, so click on the letter B in Excel. Right. Scroll down to height. Now do that for the next line, E for square.
Why does it even have this?
The letter B. Right click.
That was the
Height.
direction.
Yeah, that's what we
And
talked
That
about.
was
F.
the direction.
I do know, it's the last.
Height. Now
Leave me alone, I don't know.
3.4, like just highlight that whole thing. Yeah, all the way to 2.9 and over, all the way down and over. Not all, not that far, just there. Copy that. No, go to SPSS. And just go to like custom parts, paste it.
I have 2 extra.
Now click on variable view. Change that to low, moderate, and high, and make it decimal 0. And then just those columns to the variable view. And then make those 0, and then you should have some pretty clean data. Yep. No, we're doing stuff with it. I just want to, since I don't have a projector because they forgot to remember. It's like living space. Right, so right click. High, all the way down. No, click on the letter. We didn't click on the letter. Click on the letter. Now right click. High. Now do that on F. Click on the actual letter at the top. So you right click. High, and then do that for the letter B. Now take just the numbers from 3.4 on your top left, your bottom right 3.04. Copy. Yep, copy, and then go to SPSS. Then click on variable view. You're gonna label those low, moderate, and high for your name.
You already labeled it. I know. So big.
Then make your
Yeah,
decimal
okay,
0.
that's two.
Oh, you have to go to the values.
Yep.
Go to the values. What you doing, bro? Hello. You have to go to the values.
Okay, so actually we need to do. So what we're gonna do
Now,
is we're gonna say.
also have to.
take all your data
So just
and
hit value,
make,
would you do that?
make the low and moderate and high just below each other. So take your low. Take take your moderate,
In the second row. That's
take the moderate and then cut and paste it directly. We'll
So
save
maybe
one
the
column.
first one should-
Yeah,
Then it's your second one should.
no, below the low. Make for the birthday access, we want to make them all one giant column, and we're just going to change that label to perceived stress. So just change, instead of 3 columns, make it 1 column. So all your low values and then all your moderate values, just all the way down, so you have 30 values instead of what I said. Maybe if you do something in SPSS. So like,
Oh, yeah, it's saying.
show me.
Yeah.
Yes. Yeah, and then just change your label to perceived stress. Yeah.
Remember us going on.
Because you had spaces. You use underscores. To just, or just type in stress, or type in stress, or perceived, or you can type perceived underscore stress. So just move those all, like, all your values to one column.
Like the low.
You wanna move them, so they're all one column. That was my job. So make this stress, or perceived stress, use underscores, so space or little characters, and then make it so you only have one column. So this should be all that should be there. Yep. So what we want to do is make it all one column. So where you see where it says like low, that label should change to perceived stress. We're going to put perceived underscore stress, and then your moderate below your low, and your high below your moderate. So it's just 30 values in one column at SPSS. Does that make sense? Or I can come on. Want to make one row. So row, see where it says low? Your low, you should have low, and then your moderate should be right below that, and the one below that should be high. And then your label should actually perceive stress. I'm gonna walk around and make sure that makes sense for everybody. In a row.
So where it says 10 in the second row.
Those would be your column. So I'm saying take this value, put it there, take this value, put it below that, so you get to 30, just in one column. And then relabel your variable view just to say like perceived stress, like do an underscore. And then you can delete those columns and what we're doing next. So move, yeah, so move, you can. Yep. Yeah, so we're basically gonna make it into like, we're gonna have 2 columns instead of 3 columns. And then take your high and put it from 21 to 30. And then you can delete the data in those other 2 ones. Yeah. And then on your variable view. Yeah. Perceived. Don't put a space, put an underscore. Because otherwise it'll say it's a lead character. Stress. I need to get the door. No, it's fine. No. Sorry, not the goal. So we're taking all of these, like what she's doing, and we're just gonna move the data into one row on the left. We're gonna call it perceived underscore stress. Or what you're doing is fine tuning, perceived level of stress or workspace or stress or whatever. And we're not gonna worry about those columns, because we don't need those yet.
So we only need just one.
Row 2, the second, that was gonna say length,
Sorry.
by the way, and then the third column will say nothing.
I think so.
Length, yep. I just delete that. don't worry about it. And then click on data view. Yeah, that's fine, but you're gonna want move your length and your high to under perceived stress, so there's no values in the next two rows. No, you see what you're calling? It's the other like that. Just in that order. So do one, do one column, put it below, one column, put it below. Yeah, you got it. Yeah. And then that, yep. And then you delete those. Because I messed up the directions and I am not infallible and I don't
Yeah, I was just so forgiving.
No,
I was
not
just
me.
like, why did we put the values?
So once you have your length column cleared out, the first 10, you're gonna put the number 1, the second 10, the number 2, the last 10, 3, okay? We're not gonna worry about the high columns, we're not gonna use it. So then your length, you're gonna, yeah.
The one that I'm doing?
You're gonna put,
First 10 or 1.
So-
Second 10 or 2.
so for the length, we're gonna do, yeah, you got it, perfect.
Oh, I put.
Because I don't have the whiteboard, I'll just walk around and make sure it makes sense, right? Data. You. Okay, first 10 are 1, second 10 are 2, third 10 are 3, and then we're gonna ask you to tell us something. I don't know if you can feel, and you're gonna wanna make 0 decimals. And then what we're gonna do, everybody over here. So your next one for variable view. So
Oh, that makes sense. I get what we're doing.
right there, yep, length.
Then the second next step is 2.
And then for data view, actually go back to variable view for me. Your decimals are 0, yep, okay, perfect. And then the first 10 is the number 1, the second 10 is the number 2, the last 10 is the number 3. Because we're talking about the amount of time the employees are there, so we're talking about low, moderate, and high. That's, yep. And then 21 through 30 is 3, yep. Yeah. I'm gonna make sure he has this.
Okay.
First 10 is number 1, second 10 is number 2.
There was packing when it was.
1, 11, 12.
Under groups, are we still labeling that like?
You're not gonna have to
Okay.
for what we're doing.
Oh, okay.
Because it's, oh, hang on. No. Okay, so now under values, yeah, so then on the cancel.
So we don't need to do it.
Yeah, you're right. That is right.
Oh,
This one's right?
What your
Okay.
colleague did is right. Value 1, 2, and 3, and then
Okay.
label. So now we're gonna click on labels under length.
I know, I was so on top of
I
that.
know, maybe. Underline.
Values. Right, click that. Click add 1 low. No, go back.
2 and 3.
2 and 3. 2 moderate, 3 high. And then say okay. Got that? Not yet. For the length. So click on variable view. Click on variable view. I like how smart you are, that you're ahead of it. But you want to have one thing. Variable view.
Oh, very needed this.
Now on length where it says values. Put your mouse over
Yeah.
there, yep. It should- And then click on that. Click on the plus button. There would be 3 rows. Value 1 is low, value 2 is moderate, value. No, you gotta do it. No, it's a number. That's 1. And then label is low. And then add the plus button. 2. And then moderate. Yes, it is. Yeah.
Hello, right, type.
And then
Hello,
high.
I can't type, wait.
Or I know how to use SPSS, but that's probably.
I know, just, yeah, okay, okay.
Okay, so now, go to variable gap. And then put in the values. Click on that.
Two keys B.
Value 1, low, value 2, moderate, value 3. And then you see what it says. All right, so now click on the variable view. Click on the values under length to your right. Keep going. It says none. See where it says none? The cursor on. Click on the 3 little dots right there. Nope, not there. The one on the rows. Good. That one. Click on that, and then click the plus button. Value 1, low, value 2, moderate. So value first, you have to do just a number for now. And Carl's too. And then make sure you label those low, moderate, high.
No, wait.
It might not. Stats books are usually written horribly.
Oh, okay.
It probably doesn't say that. Yeah, that's perfect. Yeah. And under variable view, change perceived stretch to the word groups. Change that to groups. Yep. Change perceived stress to groups on variable view. Just change perceived stress to groups. Perfect, you got it. Change perceived stress to the word groups. It'll make more sense that way. And then just groups, and change perceived stress to groups. Okay, does everyone have groups at this point? The rest is pretty easy. And we're still along just fine. Okay, go to the menu bar in the data and click Analyze, Compare Means, One-Way ANOVA. When you get the pop-up One-Way ANOVA, your factor should be groups, your dependent list should be length. Don't click X, don't click OK yet. Don't click OK yet. Analyze, compare means, one-way ANOVA. Dependent list, length, factor, groups. Then, once you've done that, click post hoc. And then you're going to do lowest significant difference, or LSD. Not to be confused with anything recreationally, people. And then click on Tukey. Tukey. You want to say Turkey though? I do too. And then click, and then make sure your level of significance is 0.05. Click continue. And then save. Assuming you've done the output correct. And then I'll review a couple stuff on the worksheet and then we'll take a break. So analyze one-way ANOVA.
Oh, so what do we say?
Did you get a warning?
Post-hoc tests are not performed for length because at least one group has fewer than 2 cases.
So we got the
Mine
refund.
worked.
Skip the post hoc.
Period.
Skip the post hoc. That's fine.
Ours worked.
Yours worked?
Mine worked.
Well, then maybe you get something
Post-hoc,
weird.
everything, like 2 cases.
It worked.
I still got a warning though.
Yours worked. So then it should work for you. It's probably something entered wonky.
Okay, if the length column, at least one group has fewer than 2 cases, what does that mean?
Did you put all, do all your labels make sense on the variable view? 1, 2, 3, low, medium. It's probably because,
Is this what you're?
click on data, click on data. It worked for you, right, Katie?
No.
It didn't. Oh, change your length. That's your type of variable. Click on variable view. You have to change it from nominal to scale. That's why it didn't work. That's why you had the error message. See where it says measure to your right, far all the way over? Change that to scale. And then it should work. I would make them all scale, yeah. So that SPSS knows it's looking for a
Wait, so
number.
what are we changing the second one to? They're both gonna say scale?
Yeah, so length should be scale.
And groups scale too or no?
Yeah, that should be fine, yeah.
It still says post-hoc tests are not.
Anyway, so length, no, you did it wrong. It's the other, wait, is that what it said?
Is that what it says?
Is that what it says in the book?
Yeah.
Oh, no, that's right, yeah, factor in groups, yeah, that should be fine.
And then post hoc.
Oh, 2 key and L is continue,
Yeah, we got the same thing.
but did you still get a list?
Both are not performed for length, but at least one group has fewer than 2 cases.
Go back to your data.
Well, I don't know.
Go back up. Here's an anomaly and it worked. Okay, then make it nominal. That should be fine.
So what's nominal?
It would be,
Instead of scale.
it would be the length,
it's nominal.
The length is nominal?
yeah.
The rest are scale.
Yeah, that should make sense. Continue. But did we get the table? We got the table.
Oh, is this it?
We got the table, right? Every the table we did by hand. At least that's coming up in SPSS. You see the table, like at the top? Yeah, Nova. The between groups, within groups, total, F significance, mean square. You see
No, we
that?
don't need it.
It literally looks like what we just did on like Excel.
Is that what you wanted?
We still get warnings though, we should,
You shouldn't get a warning, but it's
Or
just
you'll
skip.
take it?
I'll take it.
Okay,
Skip the
right,
po-
thank you.
You can skip the post hoc test if you want. I just want the one way over to work.
Say,
It tells you there's more than 2. That's fine, I'll take it. I'm looking for the table right there. No, you just keep it, that's fine. Because see how bad, because we literally just did it. That's what I was trying to get us to. Yeah, just say this. Did you enter something properly? All of those are correct. We can analyze.
what did, what?
One.
No, you're still in.
Yeah, and then just do, yeah, just sort. No, makes sense. Okay. Yeah. Yes. The SAP. So 45 points. So that's a lot.
No, I'm looking for points.
And then you save them as an SAP file. Did you? So somebody was doing this. What I was.
Open. Yeah.
This. Like that's what we do this today.
So
My
that's.
dad got it.
Wait, Dr. Mann.
Yeah, she looks like a table.
Let's just go.
I wanna check something.
That's okay.
Open.
It gets-
I already submitted. Don't do it.
So I'm just looking for the one way and over.
I'm actually curious.
So like what we just did by hand, we do it as SPS on split. So now you're after that.
Hey, I think I might have figured it out, so.
What happened?
It says you have to hit signature.
Oh, for the post hoc test, everybody, the reason it's not working,
I'm gonna kill you.
you have to hit 0.05. I did say that, maybe y'all didn't hear me. You wanna select 0.05. I totally did, I remember saying that, but I might not have
I did.
said it more than once, so it might have been my bad. So when you do the post hoc test,
Let me see the
if you
picture.
don't put the significance level to 0.05, it won't work.
It was, you couldn't even say 8.0.
No, I want you to redo it.
Nice one.
We still get.
No,
more
now
like-
that we know what it is,
But it's still
it's
just.
a very,
It's the same.
you still get a warning?
Yeah.
I think, you might have switched.
Do you switch where the groups and the
Maybe.
length are supposed to go?
Oh my god.
As long as those are in the right spot,
So this should go.
try that, yep,
Link on the bottom.
and go like that, and yep, and then do post hoc.
I got a weird one. I got multiple, oh.
Yeah,
Multiple comparison.
so when you do the post hoc, switch length and switch groups, and make sure your level of significance is 0.05, then it will work.
Length of.
Yeah. So one way ANOVA,
Is this the one?
it's the same thing, compare means. One way ANOVA, take, so split them, just flip,
So length of the top.
put that,
Yeah, so
and take
length.
that, put it like that,
No,
and then
groups
switch
in the
where they
top,
were.
length in the little smaller box.
Side.
And then when
I
you
think
hit
it's the same
post
way.
at the top.
Groups, put
make
groups
sure
at
you
the
hit
top.
second one.
I think you said it was the
Yep,
same.
it'll continue.
Oh.
So
And
put
then
groups.
hit,
Did you
up
get a
here,
long one?
and the list, and put
That's
link,
what I
It's
got.
like that.
post hoc.
Yep.
Those, yep,
And
0.05, but you have that, so that's okay.
There we go.
And save it. Now it worked. See? Yeah, now you got your charts. Save that. I'm gonna look for it, so don't think you can just submit it. I'm gonna look. I read everything.
Wait, so my mom?
Wait, hold on, so groups is the first one?
So first, you do. That's for your post, yeah, for post hoc.
Why is mine 25?
There you go. Perfect, yeah.
Whoa.
What's better?
That's it. And you got the other four, yeah. They're long charts. That makes sense.
Okay, mine's not longer than theirs.
Now you're wrong.
But I did it.
So you did it and you have to do that correctly?
I submitted.
The one way. So the one way doesn't look right, so click on analyze.
This one?
Yeah, go into analyze, compare means, one way, ANOVA, and switch those. We're not gonna do the post hoc right now. We're just gonna do. No, I think it's groups at the top and like the bottom actually. Groups. Link, bottom. No, that was the post hoc, sorry. Say it around. Link, top. Groups on the bottom. And then say.
I tried. I couldn't
Okay.
press. That was no way. It was really complicated.
Scroll
Oh, oh.
I think I might already be, but it would. Between groups. Nice to meet you. Look how we know. You know what we're doing. Untitled. Outline.
Yeah. Oh, descriptive?
No, I'm like here, only over. This makes sense.
I think he's there for inside.
So from just analyze. Put your groups at the top. And at the bottom. Two 27, 29. Yeah, that makes, yeah, that makes sense. Yeah, same. So you save SPV, SAV. We'll go over a couple things and then we will take a break. All right, so.
And by Wednesday, we can for extra credit rate you on rate my professor.
Yeah. I hope I get a good rating from you. You did ask me one question I didn't know the answer to, but that never came up in 2 years.
That's okay.
So I think we got there, but I don't want to get, I want to give you a real answer. Like they never came up. That's why we had to look it up at that point. So.
I always do 1% before post stuff because it's
Well, now I know what the last chapter. I've been doing some post person.
no. I always do 1%.
So what we can do is, so remember, when the ANOVA is significant, you conduct a post hoc test to determine which pair or pair of groups means significantly differ. When it's not significant, stop. No group means statistically differ. Experiment-wise, alpha is the alpha level stated for multiple tests conducted on the same data. Fisher's LSD is the most liberal acceptable post hoc test. This test is associated with the greatest power to detect an effect. ETA squared is often reported as R squared for analysis of variance. Omega squared corrects the number of groups and the size of error in an ANOVA test. A post hoc test is a statistical procedure computed following significant ANOVA to determine which pairs or pairs of groups mean significantly differ. These tests are necessary when K is greater than 2 because multiple comparisons are needed. When K is equal to 2, only one comparison is made because of one pair of group means can be compared. A pairwise comparison is a statistical comparison for the difference between two group means. A post hoc test evaluates all possible pairwise comparisons for ANOVA with any number of groups. Experiment-wise, alpha is the aggregated level or probability of committing the type 1 error for all tests when multiple tests are conducted on the same data. The studentized range statistic, or Q, is a statistic used to determine critical values for computing pairs of means at a given range. The statistic is used in the formula to find the critical value for a Tukey's, not Turkey's, post hoc test. Observed power is a type of post hoc or retrospective power analysis that is used to estimate the likelihood of detecting a population effect, assuming that the observed results in a study reflect a true effect in the population. Be aware that there is some criticism for estimating power this way. And you may go on break and we'll do chapter 12 and 11 smaller worksheets when you come back. And then we'll do the reviews and an exam 3 review on Wednesday. That'll be our plan. 5, 10, what do you need? You can take a longer break if you want a solid 10. Would that be helpful? No, that's why I'm saying take a longer break. So it's 11:43, let's say 11:53. 3. It'll be smaller ones for 11 and 12. We'll do 1 or 2 of those today. And then I have an exam 3 walkthrough review for Wednesday. So like the first half of class will probably be your presentations and the second half will probably be the exam 3 review. So then you have just a little bit more practice to. Yeah. By Tuesday at midnight or Wednesday in the morning before class starts or before sunrise or PDF, Word document. No, there's two.
Okay.
There's an exam 3 worksheet, which I just made available. You can see now. And there's also an exam 3 review like we've been doing all semester. So one will be the exam review, which will probably be under in-class activities, where you'll be like,
It might not be available.
I can look. Is that you? What? Oh,
You know, like you those Vogue things, like where it's 24 hours, like celebrity.
oh yeah.
Yes, like it's like. With like,
Oh yeah, we're supposed to get to like hang out with them. Yeah.
like.
Or you can just go to Vegas and meet them randomly. I met I met like Mr. Miyagi, Pat Marino from Party People. Well, he was still alive. He's dead now, but well, he was still alive. I was like 16 and I went to Vegas, and I think they still do limos from the airport because they need to put more people. So I got it. So I was 16 and I got into the back of the limo with 5 women that were all like 20 to 30. They were all really pretty. And my dad got in the front seat and they rolled the divider window. And then they all thought it'd be really cute to like put lipstick on and kiss me. I'm like, sure, awesome. I'm 16. It's like the best experience ever. So then like he was in the front and they rolled the divider. I was by myself with these 5 women and I was 16. I'm like, this is awesome. So they all kissed me on the face and with lipstick marks. I'm like, I'm never washing my face. So then I went to Circus and I started like checking out Circus. And then I looked and like probably from me to Jonathan or maybe to like the door, it wasn't far away. I'm like, is that guy over there, Mr. Miyagi? And I didn't even know like his real name. I just knew him from Karate Kid, which is bad. My dad's like, well, Vegas, probably. So I go over to him, no accent at all. He sounds just like a native English speaker born here. Super kind. He starts teasing me. He's like, what is this, puberty all at once? Because like I have all these lipstick marks, right? So I took a picture where he's leaning over to like kiss me. And I had it for years, but I can't prove that story actually happened. But it did. Yeah. It wasn't the digital age back then. It was like Polaroids. But the women also took pictures of the limo and mailed me pictures. I give them like my physical address so I could break to my friends. I was like, no, this was really a thing. So. And then I went back to Vegas at age 18 and my dad got married again. And my stepbrother for like a couple years, they got divorced later, was 21. So we got loaded in our hotel room because he was 21. Not a lot, like 3 or 4. And sometimes there's too much Vegas. Like I went out there for Thanksgiving a couple years ago. I did Wednesday, Thursday, Friday, Saturday, Sunday. I wanted to leave by like Saturday.
Yeah.
Like I did Cirque du Soleil and I saw Celine Dion in concert.
Oh, that's cool.
Yeah, and like it was too much. And I'm not a big gambler. I've gambled 4 times in my life. And it was like I won money twice, broke even once, and lost money.
Yeah.
But I did get that Vegas trip for the manager did Coke, which I wasn't part of that.
Yeah.
I won $333 on quarters because I had this like intuition this machine was like hot, like this vibe. So I went over to it. I won $333 and then I took $300, put it in the safe. And then I spent like $30 either in the casino or on drinks. But I left Vegas with like winnings because I took like 20 or $40 I was gonna lose. I think I only spent 20. And I was like, cool, I won, I'm done.
Yeah.
Otherwise, you give it back to the casino.
Yeah. My
So.
parents went to Vegas. I went back to our bachelor party.
Sounds like fun.
Yeah, and it's funny because like all of my mom's friends married all of my dad's friends. So it's like, does that make sense?
Yeah.
Like, so it's like funny story.
My great aunt was my great aunt's was best friends with my grandma because her older brother was my grandma's first husband. It's not weird. You just got to think about
Yeah,
it.
you gotta think about it.
Yeah.
That's cool.
And then my grandpa remarried this woman from the Philippines who's Chinese. So I ended up with uncles that were younger than me, because he had a second family, that were actually my half uncles. But I'm their older nephew. Because he had a second family. If he would have had them when he had my mom and her two brothers, they'd be older than me. So it's a little unusual to be like the older nephew offering the younger uncle's life advice. It should go the other way around, right? Right back.
45 lessons. Guys, did you say when I checked it?
Yeah, he said like he has to turn or submit everything in by by the 30th.
Oh, I already asked you that. I'm tripping.
Because I panicked too. I think.
But the website told me to say that.
Tuesday.
I don't know, London probably. Well, right? I'm not sure.
Of course, we spend 8 hours every day, so we spend 4 hours together for the course.
Actually, I hope so.
But it didn't feel like that much.
Good, good.
Oh, by P value.
Our significant at a 0.05 level.
That's literally the next one we're doing.
Oh, okay. Cause I'm working on like slowly like the website project. Okay, I'll probably go over this.
So that's literally the next worksheet.
Okay.
So the next worksheet is in-class assignments. And what I was gonna do is I was gonna have you guys work on your own. And then I was gonna go over all the answers. And then if there's questions on how you got there, we can talk about those. And then I was gonna do the same thing with 11, which is a much lighter version. And then if we have time, we'll start the exam review, or we'll do your presentations plus my exam review, and then you should be in a good spot. So if you click on your course, student resources, in-class activities, and then you click on in-class activities 7/13/22 Part B and Chapter 12 Worksheet Statistics. And then it should just be like looking up charts and then using some of the stuff that I talked to you about.
Yeah.
and then your F scores, and then you do that twice, and then the decision, which is the math that's on the board. And then, yeah. So I'm thinking probably we should take at least 15 to 20 to work on that worksheet, so you have time to work through it. And then if you get stuck on something, I can come around and or bring up the answer sheet and see how you got there, or give you a chance to check your answers, etc. And like I said, if the answers don't make sense or you're wondering how we got there, we can walk through that. So in class activities, you're gonna go into the folder 713.2 B, the second one. There should be a worksheet chapter 12 with my name on it. And then it's like looking up something in the chart and then explains what the principles went over. Give it your best shot. I'm gonna go over the answers with you. And I was thinking just work kind of quietly and autonomously for at least 15 to 20 to give you time to knock it out. So probably like quarter after, I'll see how it really do, and or I'll walk right every 5 to 10 minutes or so. When I feel like most people are done, I will reveal the answers, and then of course, if the dots aren't connected, we can talk about how we got there.
So what we're gonna do is we're gonna go into student resources. And then class activities, and then 713 points. 713. 22 part B. Looking at it right there, yep. And then chapter 4, which is statistics, Dr. Mack. And then to ask you some questions. And then we also go for the next work, which is what we did today. And you guys at least 50 or a little bit more. And then I'll go over the answers. 5 to 10. And I can also run a laptop around and like show or I can tell you. So you don't have the current value. So that's your F table right there. So here's one. So the point of 5 seconds is the F score. And remember how we got there? Remember how we got there with the degrees of freedom? Like n-1, k-1. So like you're going with those critical values. They're going to explain basically what it's at, and they're going to calculate F scores. And if you go to the F table, so it's like table C3. Keep going. That's the right table.
I just thought it's K.
So you're gonna look those on based on we looked those up before. So we know what K is. Remember, it's K1 minus 1 and N minus K. For your denominator, like your numerator, denominator. So K minus 1 is your numerator, and N minus K is your denominator. And then that should help you for that table. What?
Can you do the first one first?
Yeah, let's make sure it was on this right page. Yeah, shoot me an email or a text. You said chapter 10. What was that? 10?
Yeah,
Yeah, I got it there. I can do that in the Yeah. Yeah, that's right.
So how does it go?
Pull that up there.
Z. So change that to K is equal to 2, K is equal to 4, K is equal to 6, and K is equal to 8. I can modify that on my side.
That's what I was confused.
Yeah, that's gonna make more sense. I can fix that. I can fix that and upload that if you want. This one. Chapter 12. K is 2, K is 4, K is 6, K is 8. Save. I'll re-upload that to Blackboard right now. So in a second, if you download it, it'll make sense, okay? See, publisher worksheet. When they were mine, it was spot on. Student work resources, in-class activities, Part B, edit. Cancel. Edit. Mark. Browse. 11:59. Open. Submit. Now, if you download it, it'll make sense. It's 2468 for the Ks. I changed them. So if you download it again, it'll automatically look like that, or you can just do 2468 instead of 12. This K should not be. Yeah, the first one. Yeah.
It's just K minus one over N minus K, right?
So would it be like 2 minutes, one was just one, and then?
So the first K is 2, so 0.5 is 3.44, 0.1 is 5.72 for K is equal to 2. And those are off the critical, those are the critical values found in the F table. That's where those came from.
Wait, repeat that.
That should be your critical value.
Oh, so you did two. What did you subtract one from it? Two minus one would be
2 minus 1 would be 1.
and then 22.
So it'd be 1 and 22. So would that be right? So let's go into,
Because it says the degrees of freedom of the numerator is K minus one, so if K is 2, we subtract 1, it should be 1.
right,
And then it says N minus K, so if N is 24 minus 2 should be 22. So
122.
which is I think 430. And.
Okay, then that's right. Yeah.
430 and then 794.
Yeah.
Okay, that's what that is.
So I updated that. So if you download it again, it says K is equal to 2468. So remember, we're doing K minus 1 over N minus K. And that's going to help you figure out what look the critical values in the F table. And then the 0.01 and the 0.05 is based on whether it's bolded or not in your table, and that's how you're listing those. Are you doing all right over here? Okay. No questions. Yeah, I would say, so it's, I would say critical values, I would say as K increases. Like I would make sure your answers clearer than just that. The next one, of course, you're going to look at what you see in the chart. It's going to tell you.
It is 16. No, wait, 7.
So you're doing N minus, you're doing K minus 1. So 2 minus 1.
I just did all the values.
And then N minus K.
4, 3, 10, 1.
No, we're looking them up.
4 and 4?
Yep.
Yeah.
277.
Yes. Yep.
266.
Yep. Yeah, we're looking. Yeah, so like it'll be 2 and then like 22. Because N is 24 minus K, which is 2. So it'd be the first one would be 1 and then 22. And you look that up in the F table. And then it'd be 4 minus 1. And then so that'd be 3 over what, 20? 24 minus K minus 1 over N minus K. Yeah, but you're
you're looking up numerator, denominator, and then the two critical values for the 0.05 and the point. So who's probably gonna write correct? So scroll up. So critical values of 0.05 level significance are in light phase, 0.1 are in bold phase type. So you're gonna look up the numerator against your denominator, and then you're gonna write down both values right there in your chart. Yeah, so 1,
For what?
and then,
For number 3?
so scroll down.
Because this cake was for.
So 1,
No.
22. So 122 is 4.30 and 7.94.
Yeah.
So the light phase is 4.94 and that the higher one is 7. Does that make sense? We're just-
So 0.5 is the 30,
Yep.
Is it number 3?
Yeah, so you're gonna do that, and then your next question, I'm gonna ask you about the pattern you're gonna see on the chart you're filling in.
Oh, I didn't scroll down. Oops. What?
So K minus 1 over n minus k. There you go. Yep. And then just make sure you got your 0.05 and your 0.01. Because you're skipping those right now. Just make sure you're doing. It's probably easier to read them simultaneously, right? Yeah, that's. Record the current values given the following value. Yeah, that'd be right.
They're all gonna be 3.
Yeah.
But then you just subtract from 4.
Well, n minus k, so 20 minus 4 is 16.
Right.
Right.
So
Yep.
then it'd be 316.
Yeah, you got it.
It's 3, yeah.
Because we got to account for the degrees of freedom.
Yeah, that's
K
what-
minus 1, n minus k.
So then 3's
Good. Yeah, you got it.
Yes. Because we-
They're trying to say. Yeah, like cheer up. Yeah, see? You got it.
It's almost like it's all at the same time with the ship.
So the first one is 210. Instead of the 4.94.
So the statistic would be your numerator of your K minus 1 over your n minus k. It'll tell you that statistic, the pain value would be the math. So you would take all of those, you'd square all of them, you get all your totals, so you know what those are. You do your intermediate steps, you plug them in, and then you get your mean squared, squared between groups, mean squared error, and then you would get your F statistic versus your other pain value. and that would
Yeah,
tell you what to do.
I didn't see the bottom. All I saw was the first
Does that make
sentence.
sense? I feel like
And
that-
then I think.
I don't have 3.28 in there, you'd have to find it. Which you would start with your K minus 1 divided by n, okay, that's your numerator, denominator, where to look up your F, just like that. And then you would do all that math, and then you would compare them and tell you, we're gonna maintain if it's below, or reject if it's above.
What did they say?
Just think that the.
Yeah, I just put it down. I got you.
So this one, you're gonna do n minus, K minus 1 and n minus k, that's gonna be your numerator, denominator, for your statistic. Then you gotta do all that stuff, I would probably use Excel, low, medium, low, high, square them all, sum them all, and then do all the steps.
All three were given. Yeah.
Ask for extension or, you know, and or text, and I can do the extension during class today, or at some point for the other day, I can extend it anything's coming for a few more days.
Yeah.
And then you get them, you just move down, I would probably say,
Wait, the
like,
web signs?
I'll extend it through Wednesday. If you all.
So I'm big time.
Create the email and text. Now I have, the thing I have to go to is like a.
I gotta.
Probably can't finish those right now. I might be able to go in a good spot. But if it's how much you want, via text and or email or both. I reply to you all and I'll give it, I'll do website. Go back and do, or the deadline is passed.
For like better scores.
Well, you get 60 attempts. So if you didn't use all your attempts, you want more time. But it's unlimited on free post, 2 attempts on the exams,
Yeah.
and it's 6 attempts on the website. But I think on attempt 2, I think it's attempt 2. If you get it wrong on attempt 2, you get 4 more attempts, and the book starts playing where it
Because someone said cool.
and I'm available. So if you're really stuck on website, you want to work something on website, inside or outside class, you can do that. Yeah, probably outside just because of the material recovery. But I'm totally available to any of you for like, this doesn't make sense, because I know it's the answer, you can work backwards.
We can't go to website today because you're in tax. We can't go back to fix it.
Yeah, you just gotta email me and I can administratively fix that. I can go like, if you said I need these 3 different websites to go back, I can go manually, I can say, make the due date Thursday or Wednesday or 40 or whatever, and then when you go back, it'll work.
What is the F ratio?
Sure, we'll say that.
So the critical value for the F for each level of significance. So F is infinity, so that should be there.
Right here?
That should, yeah.
Oh,
That
okay.
should be right there for you.
And why it's the same?
2.77 and 3 points. Well, the critical values are the same. Go back into the score. Infinity.
Yeah.
Go back.
Oh, on a different, not with the F.
They're both 1. If you're looking at it correctly.
Oh, for infinity.
For infinity.
Okay, okay. Wait, N?
What?
Low, medium, and all this stuff, is that everything that we did on the board? So you have to do all that?
You do all those steps. If you use Excel, you're gonna save a bunch of time.
It's just one.
And there might be other numbers below in Excel. I would look at that Excel sheet and scroll down because I might have done some of the math for you guys already. Do you have the Excel sheet that's attached to the previous document? That might be in there, by the way. The Excel sheet might have some of the math done for you. I think it might be in there.
So N is everything.
So N you would have, so you have N1, N2, and N3, and the total is those plus. So remember, N1 plus, oh, I erased that.
So we had 10, 10, and 10, so N was 30.
Oh.
But go back to your Excel sheet on the other worksheet. Student resources. Look at the most recent Excel sheet, the reference, yep, that third one. You can allow it, it's not. That's correct. Scroll down, I think that might be there. Do I have that for the?
Because the end value gets bigger, because we saw that they both just. So then if those
No,
two
I
numbers are getting bigger.
You can
bigger,
check.
That means these are gonna take a while.
They might, yes.
That makes sense. Okay, so here, as the word values, like get bigger.
Depends how much they know. I know it's homework. It's that I've tried not to give you all homework all semester. Really trying to make sure you get there. I understand. I don't want you to get to the exam and go, what the F is an F score. I don't want that to be a thought in your head. I want you to be like, oh, it's this. I practice a whole bunch. But if you follow the steps that we did on all of those, you'll get them right. It might just be. Are you guys doing the, and there's nothing else for it. That's fine, take a small break, right? But your concentrated semester work, I like that time in the class on assignment, so that's on you, you don't need time effective. And I have a thing right after class, I cannot do a line, which I refer to affectionately, like with students talking in the class, I do a line. If I did that, I would do a job I never get, and it's you're all.
And those.
I would be more like you're at the page.
Run over there.
So, but I will talk to any of you later today if you have questions, I just need to want to what they have.
The N is basically 4, 5.
So it'd be 15, it'd be five, M1 would be 5, N2 would be 5, N3 would be 5, and then capital N would be 15, yeah. I would make a table and I would start doing that chart on your left there.
Wait, right here?
That white one right there. I would make a chart and then I would start summing everything. What would probably work well is if you looked at the example that was in Excel from the deep dive worksheet and basically just made a chart like that. Yeah, I would basically.
Go back to the direction. Oh, is this it?
No.
Yeah.
I didn't put it in there. Oh, did I? No, I don't think so. But you can do it very, you can make Excel do a lot of that stuff for you pretty quickly. If you do the formulas right. So you can do that one, that's fine. This one's probably more the easiest because it was a squared. You know what I mean?
Okay.
But either way, I'm just saying, if you take either one of those tables and then you know what you're looking for, you just fill it in kind of alongside, it'll make this map a lot easier.
That whole thing we have to do.
There's 3.
Oh,
Or what we can do is I could see how you guys did in the first half, and then we could do 1 or 2 of them as a class. We probably can't do all 4, but if you wanted, we could do. Whatever's gonna help you out the most. Or you could do 1 or 2. We check the answers, and maybe we can do like a 3rd or 4th one in the class or something. So, however you ladies want to do it, you can do it by hand. You can use Excel and use like the template that I had. where I got the scores from. But though, I did not give you this in Excel. And depending on what you need, I can either show you an answer or two and see if you got it right. There might be homework. I'm trying to give you guys time to work in class, but it is 64 hours to teach you 12 chapters with the stats, which I think there's more time per semester. I directly after this class, 1 to 3. But I'll go with any of you outside of class. I just can't do it directly after. So this, and then your reviews, chapter 11 worksheet, which will be easy, and then an exam 3 review worksheet, and that should take us the class. And then I'll give you like probably a few days to do exam 3. That should be like, okay, I know there's lots of steps, but I'm hoping like the steps are making sense to the two of you.
They are, I like the way I did it. So that.
Okay.
Okay.
You're not gonna square
The
the capital N, no, you're just gonna do, you just need to know what it is. Yeah, there you go, okay, you got it. What were you asking me?
Divided by,
Wait, hang on, that was a sum of, so we have EX, the sum of the squares total, the sum of the values total. So we took the 3 columns, we got totals, and then we added those all together, and that's where we got the 97. Because it was 34.3, 33, and 28.8. And then the sum of the squares total. So that was all of the squares totaled. We wrote that out. So the first one's all the values total, like with the columns. And then, so like rows are like this, columns are like this. So column, sum, row, sum of the X, sum of the values total. Then square, sum all the squares in columns, and then you sum the sum of the squares total, and that's the next number. And then 1 is equal to the sum of the squares total squared. So it's 114 or 97.10 squared divided by n, which was 36, which was all of them. And then 2 was the sum of the values squared over n, but we separate them out. So it's each one of those sums divided by the total n1, n2, n3. Then we got that, and then 3 is the sum of the squares total, which I had listed previously, and I just stated. That makes sense so far? Then we go over to the. So now we did 1, 2, 3. Then we go 2 minus 1, which is the sum of the squares between groups, and we plugged it in. So 2 was 366.42, which was all that math right there. Minus 1, which was that very first thing, 65.5.97. Sum of the squares total was 3 minus 1, so that was 372.95 minus 1, which was 365.5, 7.50. And then the sum of the squares error is the sum of the squares total minus the sum of the squares between differences. So 7.50 minus 0.97 was 6.53, which makes sense because 6.53 and 0.97 should equal 7.50. You follow me so far?
Statistic,
Then
that's what that.
the mean sum between groups is the sum of the squares between groups divided by the degrees of freedom between groups, which we already had. Because if you look at our table, or if you look at like the Excel, remember it's at k minus 1 and then n minus k. So 0.97 divided by 2 was 0.485, and then the mean square error was the sum of the squares error divided by the degrees of freedom error, which we have. Sum of the squares error was 6.53 divided by 33, because that was the between groups, which is 0.98, and then to get the f obtained value, you take those two values, which is mean sum between groups, mean square between groups, divided by mean square error is equal to your f obtained value, and then you compare that against the f statistic. And in this case, we retained it because it was low. Does that make sense?
Oh, wait, I have a question. Statistic, that's what our values that we compare.
Yes, and then our decision is based on the f obtained value and the comparison to the f statistic.
So to find F statistic.
So there's f of, so it can be confusing. There's the f statistic, which is like look it up in the chart, and there's the f obtained value, which is like do the math. And then when you do the math, you see if they're to the left or right of each other. I'm gonna help you guys in just a second.
So it'd be 212. It has 3 groups, you subtract 1, 15 is your n, you subtract 3 from that. That's 12, so your statistic would be
Well, and then go find it in the chart for your critical value.
I did the first one. Yes.
Yeah, and then you're gonna do this math on the board
Yes.
to get to your f obtained value, and then you're gonna compare them, and that's gonna tell you what you do for your decision.
Yeah.
Only homework that it's due. This is my understanding of chapter 9, it's my understanding of chapter 11, etc. And probably won't do the steps.
Do the.
Or like, you should probably, especially when you're doing, okay, here's what I would do with the version of the square root, here's intermediate step, etc. And then what we do is I can.
Oh, there's
This,
3.28.
do a small worksheet on chapter 11.
Like this
And that'll
is
probably be the
some-
second half. First half probably your, so pretty much. And then if you didn't do your 6 attempts, it's 3 or 4, the other 2 attempts. And it's good to my highest score, and then I can't even go to the black list. You should around 5 or 600 is fine. But you still some low side. Yeah, and then it 4 points to that. This way you guys, etc. If you least take it, makes sense all the time. There's nowhere after the flow. The review is on next class and everything. I would say. Then your exam, your Q attendance. Maybe around campus. I've asked for more classes as early as spring to teach another site course.
Or at the tape.
He's saying, give all your
Or
classes.
as a management.
The spring run?
I don't have my spring schedule. I have my spring availability for it. You guys have my cell, you guys have my email. Railroad professors are definitely reachable. I think you can see once they assign. When I asked for like a normal, I asked for technology, I asked for. I went into Catalan. One of my friends.
Yeah.
But she knows her stuff.
I mean.
Yeah, that's, that is basically.
What?
K minus one.
I had to ask. But I don't know, apparently she's really good for her side.
15 minus 12, 15 minus 3, so.
I know her face, I won't see her when it's fall semester. I can see if I try her email, because I might have. It was always straight on.
Is there
I raised it. I raised it.
a numerator?
So. So here's what you guys can do.
So we
I'm
retain it.
holding the draw, getting points. And already works. So that happens. Or.
Yes, we do.
Absolutely great.
Three minus one. Right, so 3 minus one. I
You
can't.
say, I passed the higher math class. But you see, they say, and if they say you still need it, ask for more. And if they tell you it's college policy. it's
15.6
college
by
policy,
the
end of story. But if they say, oh, you have, because generally a higher math. class.
It just,
Yeah, but we're talking two different things. I can waive you get into the class. I can't waive university policy. They say you must take this math. You gotta take it. If you can trump it, of course, he's in the league.
Actually, it becomes one. I said.
You still need to take the math place. But would you take the math place, it'll tell you what math you're supposed to get.
It's
And
N minus,
then-
capital N minus K.
Or your transcript say, well, I have this grade, assuming this math is a higher math than that. The worst thing they can say is no. I'm just trying to get to the finish line.
3.8 divided by 12, 12 by 12. Did you get your F15 to be 1.6?
Or like a whiteboard there.
Dude, and they have a science class. Yeah. 7.8.
Oh. No, it should be there. Yeah, that would make sense. Because what's your numerator, your denominator? K minus one. So. And then what was the amount of 64 minus 3? Wait for it.
in the exactly. See the line right there? So 4.07.
That's only here, it's
4.075. Hey. You see 40?
Oh, okay, so it's.
So what's the number, right? 4.075, right? That, yeah. Because in halfway, it would be 4.08. So you think the halfway? Think the halfway. It's like that. With 4.0. Because you have to go halfway, you have to go to the 41, so halfway
There's several.
towards 4.08 and halfway away from 4.08 would be 4.075. Does that make sense?
Okay.
And then it's the same thing, and then 64, I can probably go up.
And you change it up. What?
Two 2.76, Carlos. It's 2.76 and 4.13 for N of 64. 2.76 and 4.13 for the last one, if it's not in the table. You could probably Google an F score table and it would probably tell you that. So our textbook apparently doesn't list it, but it should be 2.76 and 4.13.
It's fine if using
Really?
with your math. Use Excel to save you time. Your F statistic is what you look up, your F obtained value is what you calculate, and that's how you check. The F statistic is what you look up, the F obtained value. So you're gonna list the F statistic, which is very easy to look up. You're not gonna know the retained portion until you do the F obtained value math, which is those steps. Try not to do guys lots of homework, but last time, but we still have 12 chapters. That's right. I know it's the word steps, but if you know how to do the steps, that's what's important. We'll do. So we'll brief on chapter 11. I can certainly talk you through some of the answers as sponsor next, but you just copy and it's not going to how to do the steps. The idea is like you work through it and then you compare notes and you say this doesn't make sense. I can post the answers now or between now and Wednesday, but you gotta know what you're doing. Okay, that's fine. Looks like Ellen over here.
I know.
Looks like you're making sense. I'm not gonna tell you all, but even if the problem is, even if I would say you're putting up the if you don't practice the steps, it's not gonna be a test, because on the test, it's gonna say, what is the thing? And if you can't do the math like that, right? You know what I'm saying?
So then
You'll
now
learn that
you
with
your
the test, right?
test.
This is AG.
You don't want that to happen. So like I said, I can go or I can show you like an answer or two
Divide
today.
that by 2,
Or
which
go
is
over a
your
couple
P.
answers. All of them, and then you can work on whatever, then I can go over some more stuff, maybe on Wednesday.
I'm gonna do it
Yeah, I'm down with that, as long as you guys are checking your answers. If you were to cut, if you were to just put it in there and not, and just have the answer I gave it to you, you might get credit on the worksheet, that's not how it is. Like, you gotta be able to work backwards, like, trying to very successful. I know sometimes people want to just like, get the thing in. But it doesn't work really well. I spent 20 minutes on a project yesterday, I couldn't figure it out, because of what I had. Three eyes, three jobs. Answer was, and it will work in steps. 2.76, 4.13. I looked it up. I looked it up because I have that answer, and that's not a good record. So I'll give you that one, the other one's just to find out.
I sent it my original letters, but I think it's 2.5 points. So that's gonna be 1.27.
Thank you. What I can do last 5 or 10, so it's about 10 hours. I can give you guys a couple of the answers, or I could say, here's what the chart looks like, and here's like one F score, retain or reject, one or two of them. Because I still want you guys to work on them, and even if I were to like post the answers, which I could do, you've got to be able to work backwards. So even if you're like, oh, cool, I got it, I'm just gonna end score sheeting. It's gonna do nothing. Okay. I could do that too. If, as you said, I could post the answers in Blackboard. But I have to really expect you guys to do the steps and your work. And if you decide to like skate on that, it's only gonna hurt you when the test comes. And I'm rooting for you all to ace the test, not be like, oh, what like,
When do you want to check?
I'll give you, ideally before Wednesday, like tomorrow. Just that, but all I'm gonna say is actually like do like officially is those exam reviews.
Right.
So that way we can start with you all getting your best knowledge of it. We'll do a little bit of review and then we'll do exam review. So between what you all say to each other and what I say to you, you should leave on Wednesday feeling pretty good on the test, or at least having the tools to go on the test. And I'll think the higher of the two scores, as usual. What I was saying is that if you'd like, I can post the answers in Blackboard. I can post them right now. But don't, you're checking. And it's the honor system. And if you guys want to skate, you can, but it won't help you on the test. Like I would really work backwards and figure out how you got there. Yeah. Is it the same? It's the same data. Following is takes the. Scroll.
This one is like the second half of that. This is your first.
So that's right.
Got the same answer.
Those are different numbers, so that makes sense.
This is still the same as the first one.
What was it in question?
What is the same? It does because we don't have.
Same question with same answer. This is my question, that is some school. That's the only difference, yeah.
Yeah,
It's the same
so I'm just
question.
saying, it's just the same answer. because
It was the exact same data, the exact same answer.
Okay.
Publish needs to be less lazy.
Why are you eating them?
All right, so let's go over a couple. I'll go over couple things here. Let's see, how about? So F table, number one, K is 2, 4, 6, 8, point level of significance. I think front row, what did you, I don't think it's 3.44 and 5.72. You had different numbers, didn't you? For K is 2. For K, for 1, you had 3.72 and like 4 something, right?
No, for one, we got 4.30 and
7.94.
for K is 2.
And so, yeah, that's what I looked up. So we should have 4.30, 7.94, 2.87, 4.43.
Wait.
For 4?
K equals 4?
K equals 4, right?
Yeah.
3.1. Why did I just?
They had the answers wrong then. You looked them up.
You changed it, remember? You changed the
3
numbers
point-
so that now we have
3.10.
4.94.
4.94.
Yeah, that looks right. 6, would you have?
2.77, 4.25.
Publisher got the-
Yeah, 2.66 and 4.0.
So we should have 4.3, 7.94, 3.10, 4.94, 2.77, 4.25, 2.66, 4.03. For number 2, the critical value decreases as K increases from 1 through 8 without changing the sample size. Simply increasing the number of groups in a study decreases the critical value and increases the power to detect an effect, which you should see because the numbers get smaller. The critical value the critical value decreases as K increases. If you don't change the sample size, simply increasing the number of groups. So sample size, like how many are in each sample, the number of groups, if the K increases, simply decreases the critical value and increases the power to detect an effect because there's more groups, more people. That makes sense based on stats. Number 3, N is 12, N is 20, N is 44. So you should have the 0.5 column should be 4.07, 3.24, 2.84, 2.76. 0.1 should be 7.59, 5.29, 4.31, 4.13. 4.13. Assuming the publisher doesn't have these wrong.
What was 12?
7.59,
But the 0.5?
4.07.
Wait, what's the 44 point?
7.59, 5.29, 4.31, 4.13. These should be correct. If anything's off, tell me. This one's a publisher worksheet. The one we did before that was in depth was mine. The critical value of decreases as N increases from 12 to 64. If you look at the numbers, that should make sense. All other things being equal, increasing a sample size decreases the critical value and increases the power to detect an effect, kind of the same thing. Number 5, for the F infinity, it's 1 and 1. It's 1.00 and 1.00. A distribution with infinite degrees of freedom has infinite sample size, so it is a population because it's everybody, because it's infinity. When the null hypothesis is correct, we expect the variance attributed to the group mean to be equal to the variance attributed to the F error, F is equal to 1. If we selected all data for an entire population, then any difference greater than 1 is significant. So to like restate that, any value greater than no effect, F is equal to 1 in the population is considered significant. Would you like me to reiterate that? Or does that make sense? So the distribution, it has infinite degrees of freedom because it's infinity. So because the sample is infinite and not representative of the population, it has infinite size. So the sample becomes a population when F is equal to 1 because it's representative of everything. Does that make sense so far?
Yeah.
When the null hypothesis is correct, so when we're going to retain, the variance, how the scores vary, attributed to the group mean to be equal to the variance attributed to the F error because sample is population. If we selected all the data for everybody, then the difference greater than 1 is significant. So if the F score was higher than 1, that'd be the reject. If it was greater than 1. Or if we did 0.01. Bigger amount population, you can make a bigger broad generalization, and it can be a lower score because the significance is more people. So anything greater than 1. Trying to find ways to say it, restate it differently. Let's see. I know we were kind of 5 minute research aside. Okay, so I'll give you the first F statistic. First F statistic, you should have sum of the squares between groups, 15.6. The error, 52.8. Total, 68.4. Degrees of freedom, 2, 12, 14. Mean square, 7.8, 4.4. F statistic, 1.773. Your significance is 0.0212, but that would probably be more of an SPSS thing because I didn't show you how to do that by hand. So your F statistic is 1.773, and against the F obtained value, you would retain the null hypothesis. So if you got that right, you're probably doing the math correctly, and we'll go over some more answers on Wednesday. The first one was retained. The second one is retained. They're both the same. They're actually the same. They're actually the same answer for 1 and 2, for one reason or another. Do y'all feel better about chapter 12? So all you need to bring to class on Wednesday morning before class, don't be doing it during class, is your walkthrough PDF, Word, or PowerPoint, preferably PowerPoint or PDF because it's easier visually, assuming they're fixing the projector. If not, you can post it in the discussion board or talk about it or screen share on here. And then we'll do that. A little on chapter 11 and exam 3 review. That should take us through the 4 hours. Get you ready for the exam. You're all awesome. I'll see you in 2 days.